Yeah, apologies for that technical complication.
Who cares? Don't worry about
Here
it.
now.
Okay, I'll just send you the recording file afterwards via Google Drive link or something.
Yeah, that's
But yeah,
great. Thanks for the
what
suggestion.
exactly do you want to? I'll just tell you what I worked on so far and how it went. So
Yeah,
wait,
sure,
how
go
much do
on.
you remember exactly from the project?
I remember very little because
Okay,
I
that's
admit
fine.
that I also wasn't so engaged. So you could
That's fine. I'll just
provide
I'll
me
just
the
start
whole
from the
view.
beginning, and if there's anything that doesn't make sense to you, just stop me and tell me, right? Um, but yeah,
Yeah, I
there
know.
is also the wiki, GitHub ABGI/mono/wiki, right? You have the link to it, right?
Yes,
Okay.
yes.
Um,
You sent me.
okay. Yeah, so basically I mean the fundamental idea is kind of simple. That instead of having an imperative reward system, you have an autonomous reward system like the dopamine, serotonin, and whatever systems. The problem was obviously that there's no scientific consensus exactly on how the dopamine system detects novelty, for example, or how the serotonin system detects your own furthering of status or power over the outside world, let's say. So we had to do a bunch of theorizing on that, like how exactly is this even possible on a cellular level to detect these patterns? And what I got to was basically that you can look at the order in which these emotional structures, let's say, evolved. So as far as I could tell from what I researched, and I don't remember exactly where I got this from, but basically first the cortisol system developed, then the dopamine, then the serotonin. And it makes sense because they're all dependent on each other in that order. So, for example, if you try to make a dopamine system, by the way, the pattern that the dopamine system detects is diffuse signal diffusivity. Essentially, if signal directions are physically far away from each other. Because, wait a second, can you look at what's a good? Let me just check a good wiki page to explain this a bit better. Because if I just send you a
Yes, sure.
drawing, it's less obvious in the recording. Um, oh yeah, non-hierarchical
Yeah, I
neural
remember.
structure. Yeah, can you go on the page non-hierarchical neural structure on the wiki?
Let
There's
me
like a
find the
menu on
link.
the right side.
Yes.
You got it?
Non-hierarchical neural structure. This one? Yes.
Yeah, exactly.
I
Just look
got
at like any of the, let's just say the third picture where you can see the like three synapses of 0.7 and two neurons have created an action potential, let's say. Okay,
yes.
so the basic idea is that because the cortex, let's say, works has the function of creating abstractions, you could say, it essentially means that similar concepts are physically close to each other, or related concepts are physically close to each other, because that's just how it would evolve naturally. And you can see this in experiments. If you look at the study where they basically did like they did some glucose consumption level brain scan on people who played Tetris in 1992. So none of the people initially knew Tetris, but eventually, like after 12 weeks, they were well practiced. And the physiological changes in the brain were essentially that glucose consumption of the brain when playing it went down. But the interesting thing is initially, and this is also in the video, right? That I sent you. The that over time the area that consumed like 40% above average glucose levels basically became tinier and tinier, and it was an area in the anterior cingulate cortex. But the point is, it was a very, very small subsection of the ACC. So essentially, there was like a particular sub area specifically for that function of playing Tetris. So essentially, specialized areas for a general task in the brain are close to each other, obviously. So essentially, what the dopamine system measures you could say, is how easily things fit into existing categories that are already established in the cortex. Um, and the thing is, if you then code a dopamine system that only measures signal diffusivity and creates a dopamine reward based on diffusivity, then you'll get what happened in the past when people tried to do this, where the ML system just gets addicted. For example, it just constantly looks at static screens, for example, like a flickering TV or something, because the problem is that it measures diffusivity exclusively as a reward, and that's because you didn't code in a cortisol system, which is essentially a stress danger detection system. And that thing also measures diffusivity. So it's essentially, first you need a cortisol system that essentially just creates a repulsive reward, so a negative reward, you could say, when confronted with information that creates a diffuse neural response. And the dopamine system creates a positive reward, essentially when it's on the edge, on some sort of edge that's genetically inherent between like not so much diffusivity that it creates a stress response, but also enough diffusivity that it actually triggers the dopamine system. It's like it has to strike the right balance between both. So that's the first part. Like if you want to create a dopamine system, you need to code a cortisol system that acts as a repulsive force from uh, at a certain ceiling of diffusivity, and below that ceiling, the dopamine system would essentially be active, and that's how you code exploration, right? Um, you got all that? Just tell me if there's something that doesn't make sense.
I would need to look at it in more details and
Okay,
study it
sure, sure.
myself.
I'll also be
Yeah,
making a
definitely.
YouTube video specifically about cognition, but yeah. So, okay,
Yeah,
that's the first. Like, I'm giving you the most basic layout possible, because you could also code the serotonin system, but like, why introduce that complexity from the start? Like, it's just kind of unnecessary when you're already doing something that's on the edge of what's already being done. Um, Okay, so that's the first piece. The second piece that's necessary is that the machine learning model has to somehow be able to affect the outside world, and it has to be able to affect its inputs. So let's say that you have a machine learning model that views reality through a camera. Like this is what I was doing, right? I was planning on creating a shoulder-mounted camera that the machine learning would control, because then it can choose its input, so to speak. A child, like a 2-year-old child, if it sees a football, it will immediately run towards the ball and kick it and play with it because that's its prioritization mechanism. Like you have to build in an approach system because otherwise the dopamine system just exists, but nothing happens because of the dopamine system. That's the problem. So essentially, the second piece necessary to make this work is that you have to let the machine learning model control its inputs. So what I was in the process of building was a shoulder-mounted camera. Like I finished building the first prototype, but it was just a shoddy plastic and glue thing that I control like with an Arduino, which is really easy to learn. Um, like the Arduino chip board thing. Like it was just 20 lines of C code. I can send you the whole code if you want. But basically, you put the machine learning model on your laptop and it just runs in the background the whole time. And then you connect that via a USB cable to the camera, essentially. Like through an Arduino that reads the inputs and then translates it into the camera angle. But you get the point. Like the machine learning model runs on the laptop and it controls a camera via its output neurons. Like those are the output neurons of the machine learning model. Because if it doesn't have output neurons, it can't do anything. It's like I said in the video. A brain is useless if it can't do anything or if it can't have any outputs, right? Um, And also, if you put it on the shoulder of a human and it learns that way, the idea is that it learns concepts in a way that's as similar as possible to how humans learn, just by observing things. Uh, yeah. So I finished building the camera. Like I can send you the code to it. And that part is surprisingly simple. What I went to work on then was the code for the machine learning model. So, so, what you were saying something?
Following along.
Okay, yeah, sure.
Good. Yeah.
Yeah, it's a good thing I'm recording this, I guess. Um, but yeah, so
Yeah.
and okay, so let's say yeah, okay, I'll tell you how it went when coding the machine learning model itself. So in the beginning, to generate, wait, how much coding do you do, or how much coding do you know?
I would say around beginner to intermediate level. I've studied
Okay,
in
but you know
university.
what,
That's
like,
mostly.
okay, yeah, I get it.
Uh,
But like, I don't know, let's say in Python, you know what dictionaries are and whatnot, right? And and how databases
yes,
work.
definitely. I have.
Okay.
You could say yes.
Uh,
Yeah.
okay. Good. Yeah, because this is so logic in terms of logic. This is so basic that you don't need any advanced algorithms, except for one part. But I'll get into that. I'll actually send you the code too.
Yeah.
Like I'll send you a link to the repository. But okay, so basically, um, I'm still doing this in the way where there's different layers of neurons, but they have 2D coordinates in their respective layers. So it's not fully a 3D coordinate system. But, just because coding it was getting so complex, that was just going to have to be good enough. So basically, when I was coding a program first that just generates the neuron layer. So this didn't have to be efficient processing power wise because you only do it once, and then the neurons are generated, and then you can use that information. I just saved that as an object. Wait, I can screen share and show you, so you have some idea. Just a second.
Hmm.
Share my screen there. Uh, yeah. Right now I have a web development thing open in VS Code, so just give me a second.
It's not showing yet.
Yeah, that's why I'm still looking for the right file so that I can show you the code. Um,
Sure.
just give me a minute. Yeah, this really is frustrating. Maybe an open recent in VS Code I can. Wait, can you hear me?
Yes. Yes.
Okay. VS Code is freezing. That's unfortunate. Okay, but basically, really unfortunate. But basically, I was just saving each individual neuron as a dictionary or an object in Python. So I was saying like everything has a unique ID, um, and all that. Like I give it like each connection, like I give it an ID to the other neuron. Basically all the information you would need to generate a neural network, right? So I had to do that with like just a yeah. I'll send you the code, and then you can like look at it in more detail. But
Yeah. This is the
basically,
Python
you
code.
want
Yeah.
the new yeah, it's a pipe, but it didn't work. Like I stopped it before it like ended up work. Like some of it is working, but only the code that generates the first two layers works, and everything else is still like that's where I stopped. Um, it just got really complicated because between two, let's say you want to connect two layers. That's the step where I quit. If you want to connect two different layers, you want the neuron from each layer to connect to the physically closest neuron in the next layer. and that's based on these coordinates that they all have. So the problem is because there were like a few 10,000 or a few 100,000 neurons in each layer. I was, you there? There's some weird noise in the background.
Yes, I'm up. Yeah. Yeah. Let me reduce sensitivity, perhaps.
Okay. Um. Yeah. Okay. All good. Anyway, so if you want to connect the two layers you want, and they all have 2D coordinates, you want the neurons to connect consistently with those neurons in the next layer that are physically closest to each other. So it took me a while to write an algorithm that actually doesn't just take, days to run. Because, you have, if you just brute force it, you have to check 300,000 neurons one by one, millions of times because every single neuron has multiple connections. So I had to do some binary search stuff to get that working. And binary search in a 2D uh, coordinate system is just, it took a while. But yeah, the thing is, it's necessary to get the connections grouped correctly between layers, because otherwise diffusivity is meaningless. Like if there's no order, like if you just connect randomly, then novelty and signal diffusivity, like generalized signal diffusivity, won't necessarily correlate at all, as far as I can tell. So, yeah, okay, so as a summary, if you want this thing to work, you need to code a cortisol system that detects generalized diffusivity, like signal diffusivity. So, meaning that the signals coming in are relatively physically far away from each other. That's diffusivity. Um, and that's what the cortisol system does, and that acts as a repulsive slash negative emotion reward, so a negative reward. Once you have that, you can code a dopamine system, which essentially does the same thing as the cortisol system, except that it's at a slightly lower threshold. Like, let's say that you can imagine it like this. Let's say the cortisol system acts as a repulsive force against, let's say, the top 50% of diffuse inputs, and the diffuse inputs that are, let's say, at 40 to 50% of potential diffusivity, that's what the dopamine system reacts to. And anything below 40% isn't diffuse enough to generate any response. You kind of get what I mean?
I would be
It's okay if
investigating
not.
further and asking. Yeah, I will ask you questions. Do you prefer I ask you on the spot or after you finish
Yeah. Ask me whatever.
summarization?
I'm glad anyone's trying to. Yeah.
Yeah, so this is one of the questions I intend to ask is explain more about diffusivity.
Okay,
Diffusivity?
diffusivity. It's
Yeah,
yeah. You can think about it
diffusivity,
this
yeah.
way.
Yeah.
Okay, let's say
So
you
what is it
have
though? What's analogous to it?
Let
So
me
there are two
explain.
parts to it,
Yeah,
right?
diffusivity and how you measure it. That's key. Yeah. Let me explain. Okay, so imagine that you have a grid of 100 by 100 squares. So 10,000 squares in total in a like I don't know, 10,000 pixels on a screen, for example. Imagine that.
Yes.
And let's say that at any given time, 10% of the pixels on the screen are white and the other 90% are black. And that's always the case, right? Okay, you get that you get what I mean? Okay.
Yes,
Okay, so
it's
let's
clear
say
in my
that
mind.
okay, good. Yeah, just keep imagining that. Okay, now imagine all the white pixels are at the center of the screen. Okay?
Yes, okay.
That would be maximum signal concentration. So the opposite of diffusivity.
Hmm.
Because the what's it called? The active pixels are all grouped together as closely as it can be. Okay, now imagine that instead it's just random. Like randomly every 100th or every 10th pixel is white, but there's no pattern at all. Or let's say that it's every 10th pixel if you go by row by row by row, just every 10th pixel is white, right? So it would just be a bunch of white dots scattered on the screen. That would be the most diffuse signal input possible, right? Because they aren't grouped
Yes.
together. They aren't physically close to each other, the active pixels, right?
Mm.
The same principle
Yes.
applies to
Diffused. Yes.
neurons. Yeah, it's like yeah. So
Yeah.
you can have the same total color on average, let's say, but if it's concentrated, it's black and white, and if it's diffuse, it's just gray. Because the white and black are like, they're scattered in between each other, so the image you get is, you can't see the distinct pixels, let's say. That's the whole idea
Yeah.
of diffusivity. So that's
Yeah.
the whole idea.
Yeah. Let's move now to its significance. It's artificial system. So, how does this concept relate to what you're trying to explain?
Oh wait, what concept?
So diffusivity. That's what you've explained now. So,
Yeah. Okay, let me explain.
what's its
The way it
relation?
relates to general intelligence,
Yeah.
is that what you mean?
Yes. Yes.
Okay, that's okay. I can explain that too. So when I say general intelligence, what I really just mean is that like a system that can learn by itself, and that how do I put this? An artificial system that learns the same way that humans do. Um,
Mm.
the adaptivity of the human brain is what has to be replicated. Because, for example, the dopamine system measures novelty regardless of the context. If you're in a Stone Age environment, it measures novelty, like in terms of, I don't know, plants that you haven't seen before, let's say. Or it measures it in, yeah, it just measures it in terms of things you don't understand yet, but that also aren't threatening. And here now in our modern world, it also measures that. So it's like the dopamine system just responds to a specific kind of information pattern instead of being a reward system that reacts to something predefined, like in traditional machine learning. The guy
Yeah.
writing the code says, okay, if it detects a cow correctly, then you strengthen the connections or whatever, something like that. So essentially, the idea is that if you apply the kind of the abstract or the kind of the all-encompassing nature or the all-encompassing novelty detecting nature of the dopamine system, you can have the same generalized intelligence as you have in machines as you have in humans. So that's the idea. If
Mm.
you replicate the reward systems, you replicate the general intelligence aspect, assuming you have enough neurons.
So I'm intending to go to the project from the start. So let me try to first to understand what is it we're trying to do. So, as you've been saying, that we'd like to create an artificial system that learns somehow similar to the human mind and it
Yeah.
have this kind of flexibility and in terms of
Yeah.
the
And what would it
rewards.
actually do? Is that what you mean?
Yeah, it's like it's not
Okay.
fixed. What's
Yeah.
its
Yeah. I
reward
see
or
what you
objective?
mean. Yeah. Like for
And
humans, the reward systems are not purely cognitive, obviously. Like eating and all that. Like their inherent self-preservation instincts in humans that I don't think there's any real way of copying that to machines. And this is the part
I,
where I think you can. Hmm?
I'd like you to go over it again because I think you made good explanation or distinction of how there are these different parts of the human brain that you'd like to somehow,
Different parts? Oh,
uh,
yeah, I mean, I
like the
don't know
dopamine
if
system
you,
and the cortisol system. How
yeah,
do
I mean,
these
for
relate?
example, to each other, you mean, or how do you translate it from human to AI, or what?
Yes, exactly. So, what's the significance of having these different systems that we're trying to replicate onto AI? So, what's the main objective of that?
Well, the main objective is that if you have a machine learning system that understands concepts the same way as humans, that then whatever tasks you want it to do, it can do in a much more versatile way. Um, Now, the problem with that is, as soon as you decide that, okay, this machine learning model will exist as, I don't know, let's say you want, like the most obvious case would, for example, be that, like, let's say analyzing an Excel spreadsheet and like making decisions based on that. That would obviously be extremely well suited for an AI system, um, because it would be reading digital data. Um, But in order to motivate it to do that, you would have to replicate something that doesn't exist in humans in the same way. Because let's say you program in another reward system that that automatically prioritizes whatever you tell it to. Like it recognizes the voice of its owner, let's say, or something like that, and it does whatever you tell it to. And let's say you give it control over a computer or something so that it can actually do something. This would have to happen after it has already learned how language works, for example. Um, so the idea is, theoretically, obviously, this will be a very difficult part, right? The idea is that once it has learned language through the dopamine system, and you might even be able to just connect. Let's say you take language detection systems that already exist and you just connect it to a dopamine system neural network so that you don't waste a bunch of time just until it learns what different words actually mean. Um, so the inputs it gets are already the words, so it could more easily learn language. So once it's learned that, you would have to essentially program it to take the language inputs that it's gotten and automatically want to execute that and have that be a reward system. Yeah, like
But,
basically a slave, you could say.
so, it's kind of now the dopaminergic processes that are in
Hmm?
it. Somehow they are what's propelling it to act.
Well, the dopamine system has a very specific role. It's for calibration and for what's it called? And for exploration.
Hmm.
It's also
Oh,
reward anticipation, but that's not necessary to replicate in our context, I think. But those are the roles. Like I don't know, when like kids are moving around or playing or something, that's basically them calibrating their own nervous systems to control their bodies based on acting in the world, and that's based on the dopamine circuitry. So it's
so
essentially the dopamine
are
system
we?
exists in order so that you understand things you don't yet understand, something like that.
Oh,
And
are
you
we
detect things you
utilizing?
don't understand because the signal is diffuse. That's the idea.
I'm getting a bit. So, are we utilizing the neural circuits in this case for the learning process as well, or what is the objective
Well, yeah,
of
because the learning process circuitry is identical to the positive emotion circuitry. It's like, you can physically drip dopamine on top of any neurons and it'll make them grow if they have nutrients enough to create the growth process. It's like if the dopamine system prioritized that this group of neurons elicited response, then what's it called? Yeah, then those neural groups get reinforced directly by the dopamine system or by dopamine neurons.
So what happens? So what can we visualize such a system to be like, or how does it act? Is it expected to be like a spontaneously acting world, doing things on its own?
Okay, yeah, I can give you. Well, you mean how we could expect it to actually act in the world? Okay. Um,
Yeah,
well, I think it's
because you
important to
said
keep in mind
also.
here that yeah, that's fine. The initial training process to get it to a level of general intelligence, and then the actual application process, they're very different. So the application process, I mentioned the controllable camera, right? For example, you could just have it be an AI system that controls a camera or a flashlight or something, based on like I don't know. Like once you have the general intelligence part, you can program in any other reward system on top of the existing machine learning model, and then it can just do whatever. Like you can motivate it to do whatever if you already have the general intelligence. So, and in order to
Yes.
first get to the general intelligence, you need dopamine system-based calibration of language comprehension, concept comprehension. If it works correctly, here's an example. If it works correctly, then you can, for example, place the camera on a table and have 5 objects put in front of it. And like, let's say they're all the same color or something, or the same shape, to make this really simple as an experiment. And then you put something in front of the camera so it can't see anything, or you turn it off temporarily, and then you place another object on the table that looks very noticeably different. And and what you would notice then, if this works, is that the camera would turn so that it focuses on the new object. Oh,
Novelty
this is something I
detection, right?
completely forgot. Huh?
Novelty detection, right? You have stated.
Yeah, exactly. And the novel, and this is the connection between novelty and learning, right? The novelty detection prioritizes the unfamiliar object, assuming it isn't threatening, obviously. It prioritizes the unfamiliar object, and then the unfamiliar object becomes familiar because of the focus. Because the dopamine system makes the neural groups grow that respond to this new concept, and that makes the signal less diffuse in and of itself. Because you then create a specific group of neurons that respond to this new object via the dopamine system.
Oh, let me revisit this example a bit. So let me understand a bit more. So you said diffusivity again. Is it related to learning?
Mm-hmm.
Can you explain it more? How is
Yeah.
diffusivity
Okay, it's
related to
related to
learning?
learning because you can only learn things that are unfamiliar, right? Um, that's the fundamental idea uh, behind learning. So essentially, this whole premise rests upon the idea, which has only been tested in biological brains, but it would probably be easy to test in AI. But I don't know anyone who's tested it like that. But basically, unfamiliar inputs give you a diffuse neuron uh, reaction slash activation. Like, wait, I can send you the picture again. I mean, you remember from the video I made, the part where with the Tetris experiment, that initially there's a massively diffuse neural response when you're unfamiliar with the game of Tetris, but once you've learned it, there's a much less diffuse response. Hold on, let me send you the thing, the picture again.
I haven't gotten to that part of the video.
Oh, okay.
Interesting.
Here it is. Just give me. Yeah, here
Here,
it
let
is.
me
Here it
see.
is. So in a naive
Oh, yeah.
state, the neurons are, yeah, now you get what I mean, right?
So naive
The
is
naive state is a
when the
person who's playing Tetris but hasn't played it before, and the practiced one is someone who's been playing it every week for 12 weeks. You
oh
see,
then we
the practiced one has a concentrated neural response. The naive one has an extremely diffuse one.
it's like the practiced person have developed, we could say, a dedicated neuronal grouping for the game of Tetris.
Yeah,
That
it's basically developed like there's no particular neural activation in lower order parts of the brain, just in the anterior cingulate cortex, like a small part of the anterior cingulate cortex. That's the specific part that handles the decision making for playing Tetris. Once you've learned that,
oh,
essentially.
okay. So let me get
But you get
deeper
the
into
point.
this.
Like playing games is fun, right? This is why.
Yeah.
Because games that you'll have to learn create a diffuse response.
So I want to understand this more. So what is exactly a response? So when does the response
Well, a
happen?
response is when a neuron creates an action potential.
When does it
Because,
happen in practice?
neurons
So
only ever create action potentials in response to other action potentials, which at the lowest level are triggered directly by outside world inputs. Like, I don't know,
so
at the
is
very
it
lowest level, the.
is it like a continuous
Go ahead.
process? Like we are continuously engaging with the world and exploring it, learning stuff about it, and the novel experiences, they have this kind of signature, how they affect
Yeah,
us.
they create a diffuse response. That's what makes them novel. If they weren't novel, they would simply be slotted into, what's it called? They would be slotted into categories, which are, categories in the cortex are essentially just self-reinforcing feedback loops. It's like, I don't know, like let's say you have all the letters of your brain, letters in the alphabet in a particular area in your brain, and they detect those letters. If you detect one letter, then it inhibits all the others for that specific object, let's say. Like, I don't know, if you detect an A somewhere, then that particular object that you're classifying as an A, like that inhibits the other letters, basically, because it's an
It becomes
exclusive conclusion.
it becomes more
Okay, wait,
holistic in a
let me
way. Yeah.
rephrase that. Conclusions are inherently exclusionary. You can't have two contradicting conclusions at the same time because that's not a conclusion. So if something is a conclusion, it inherently creates a concentrated response because
Hmm.
that's what conclusions are.
And con-
They are like small parts of the cortex that respond to a very particular input.
Fascinating.
And if you don't
So
have,
yeah.
yeah, but if you
So
don't have a group of neurons that is specialized in terms of responding to the inputs you're getting, then the response is diffuse because it doesn't get slotted into any conclusions.
yeah. So conclusions are like learned material or learned concept.
Yeah, exactly.
Already.
All conclusions or concepts, because concepts and conclusions are really the same thing neurologically, as far as I can tell. Um, what was I saying? Yeah, right. They are all based on positive emotion. Like conclusions exist because, and this is also in the video later in the video, but all the conclusions that you have in your mind and all the concepts that you have in your mind exist because a positive emotion system decided that it's important, basically, because it's positive emotions uh, that reinforce neuron connections.
Let's expand on this a bit. So you said that these these learned conclusions are a result of material that was deemed positive or important to us. So how should
Yeah.
we
And different positive emotion systems deem different things important.
Yeah, but in relation to humans, we have like this instinctual part of us that dictates
What did you
certain
say?
things. I mean, for humans, obviously, we have the instinctual part
Yeah.
that determines
Mm-hmm.
certain things as being having great amount of importance. That's I would
Yeah.
assume is genetically written in us. So I'm wondering how that would turn into an artificial system, and what would
Well, oh yeah, yeah, I get
decide
that. I
as
get that. Yeah.
important.
So basically, importance is like weight, you could say, or it's like importance is like a number or a quantity, you could say. You know, because some things are more important than others, basically.
Yes.
And remember what I said
And their
about
importance,
a
and their importance dictates how well let's say,
whether they get
solidify.
slotted into the prioritization system and the targeting system. If something is
Yes.
important, it yeah, so there's like a system in your mind that is it has to be to a large degree genetic, even though I really couldn't find any good studies, unfortunately. But it doesn't make sense for it not to be strongly genetic because animals obviously have the same kind of instinct. Like if they prioritize something, they move towards it. And essentially, oh, I mean, this is how the dopamine system works too. It's like if something is fun, you want to do it more, and you do things that enable you to do it more.
Yes.
So yeah, so basically the thing that at the moment, at any particular moment, the thing that is signaling the most positive emotion is what gets slotted into the prioritization system. Now, this is kind of deceptive to say because humans have a prefrontal cortex that is so complex that you know, we can decide to do different things based on prefrontal cortex activity or anterior you know, or ACC activity, like, you know, the higher order areas at the front of the cortex or close to the thalamus,
Yes. Yes.
like logical thinking, you could say. So, you know, it's not like, and you know, the higher order areas become more and more and more inhibitory. Like the proportion of inhibitory neurons becomes greater and greater because again conclusions are mutually exclusive. um, but yes, basically, um, once everything is decided, it's like something gets put in the prioritization system, and that's what you do. But I'm not even sure what exactly the prioritization and targeting system is even. And I don't think it's necessary to code it because ultimately it can be learned through simple reinforcement learning because, for example, let's say the AI system moves the camera so that it looks at something that it wants to look at. You know, eventually, because that produces a positive emotion slash dopamine response, it will simply learn to create the right signals in order to move the camera correctly. Um, but yeah,
Yeah, you mentioned
that
weights
went kind of
also.
off track.
Yeah,
Yeah,
I
I mean, it's
assume
just
that we
different ways
could.
of saying the same thing.
I assume we could control the weights. We, as the designers, could make it
Yeah, but that would be
all
completely
them.
counterproductive. Like you could, but it would mess with the entire. It's like the whole reason for doing this is that you have autonomous reward systems. That's the whole point. Um, if you try to control the process, um, you're just going to mess with, like the dopamine system and the cortex and the all the different emotional systems in interplay in the cortex. It's like they're all self-corrective mechanisms that exist in order to yeah, in order to put exactly the right thing in the prioritization system. So And the whole point behind this entire project is that the pattern detecting emotions are far, far, far better than any outside human input control, because they respond to pure abstractions essentially, instead of some rational decision you make, like, well, I want the machine learning thing to do this, so I'll strengthen inputs or strengthen neural connections. I mean, whenever it does the thing I want, right? Like that's inherently far less generalized than having the emotion replicating systems.
But we also distinguish that there is a subsequent stage to it of guiding
There's a sequence to it.
I mean, after an initial learning phase, could guide it forward to whatever objectives we had. I think you alluded to that.
Yeah, exactly. Once it once it can comprehend outside inputs enough to understand what you want it to do in some way, um, yeah, then you can eventually get it to learn to do any task you want it to, really. But what's important is that you get to the point where it has generalized intelligence to begin with.
Right, so let's see, where were we that we've gotten into this topic of braveness?
I don't remember exactly.
You
But there is
know,
one other thing I forgot to mention. Um, that one thing I also coded in, which made the process way more complicated of coding the neural network. Um, I made it. You know what the fovea is?
obvious, no,
Oh,
sounds
it's
like
the so when you look at something, you focus on it. That's because 50% of your receptors, roughly, in your retina are concentrated on roughly 1.5% of the area or something like that. So like half the information you get from your eyes is on a tiny, tiny point. And that makes sense because then you can, that you focus on things. It's like you focus on what's useful. So I coded in the same thing in the camera thing. Obviously, I can't physically put more, put a better camera in the center and have a worse camera read the sides, let's say, like the non-center pixels. But what I did do was I coded the connections so that about 80% or 70% of all the neurons in the network were connected to like the 10%, like the neurons in the center base, the pixels in the center of the screen, basically. Um, because you don't have infinite resources, so you need the machine learning model to focus on whatever it decided to focus on. And this way you even further increase its ability to make actual decisions because it has to fine tune what it's looking at even more that way.
so. Let's see. You've mentioned that you faced the troubles in developing the machine learning model, and mentioned this thing about how you decide the proximity of neurons, something like that. So
Yeah.
can we return to that? Why is that significant, or why are we even
Why is that
like
important?
yeah? Why is it important?
Like that neurons are connected to like in a coordinate system that they're connected to the ones that are physically close to them, you mean?
Yeah, I'd like us to explore this further.
Okay, yeah. Well, and this is something I'm not sure is essential, but what I did notice is that whenever there's any genetic wiring in the brain, for example, the nerve that goes from the eye to the visual cortex, um, the the neurons themselves don't get tangled up or mixed up. Like the neurons that connect to the neurons that let's say, encode information that comes from the top of the retina, ends up at the top of the nerve once it reaches the visual cortex. Like, how do you say it? It's like okay, here's what you can imagine. Imagine that a TV or something or a screen, like imagine you had like a glass fiber cable where it directly has the image on it, and if you put it on a projector or something, you directly get the image. Like there's no encoding of like RGB values. It's just like imagine an image on a cable. That's a good way of saying it. Um, if you if the wires and let's say you have like 10,000 or 100,000 glass fibers in this cable, and they all encode like 1 pixel of this hypothetical screen, right? Um, if you tangled up the wires, then the image would come out wrong, right? It's the same as if like you randomly switched up the pixels in your screen, basically. So like the image has to be like the order and relation of the pixels to each other, or the relation of the neurons to each other, is always maintained in the brain. Um, it's done with something called semaphorins. I can text you that word if you want. But
Sure.
basically, I think that
So,
semaphorins means
oh, yeah.
traffic light in Italian or something like that. But okay,
Interesting.
so basically, what I think is that if you tangle up the wiring at any point in a way that makes it more chaotic than it, in a way that makes it chaotic, you probably mess with the entire diffusivity thing. Maybe. Now, I can't prove that, but I very much suspect that it's the case. Because, like, because diffusivity means physical distance between different signals, let's say, and that
Yes,
they
you have
don't
a
reach a
point in that. Yes.
concentrated point or a conclusion. Yes. So I think that if if you don't connect neurons in this machine learning model, if you don't connect the neurons in a way that mimics like physical proximity, so what I did is everything has 2D coordinates, and between layers, let's say, okay, this is the function, like the coding function I did. It's like for each neuron in layer one that you want to connect to another neuron in layer two, first you check how many connections is the neuron in layer one supposed to have. So let's say it's 9. That means you want to find in layer two the 9 neurons that are physically closest to the neuron in layer one. And then you have to check the entire, you check all the neurons in the in layer two, and then the function returns you the nine the IDs of these 9 neurons, and then you connect to those ones. This is exactly how it works in the brain, because obviously you physically you have to physically have 2 cells close to each other so that they can have a physical neural connection. And yeah, I believe it's necessary to mimic that, and I think otherwise this whole thing of signal diffusivity gets messed up completely, because signal diffusivity is inherently also based on physical space. So if you stop mimicking the physical space, I think the whole thing gets thrown off.
So we're
Does that
trying
make sense?
to, yeah, I'm getting it. So we're trying to create a new sort of model of in learning models. So in the way they are usually constructed, we could say that they are one-dimensional, as in there's not much of the notion of space or area in terms of the neurons. They just
Yeah,
connect, each layer connects sequentially. But we'd like to have
yeah. And that would be
guess height.
fine, theoretically. But because images are 2D, you can't do that. And once you go from, what's it called? And once you program things in like depth perception, you have to go 3D, I think. Which in like mechanically that doesn't make anything different, but it's just more of a pain in the ass to code basically. Because like I was fighting so goddamn much with making like the for loops that first checks one row and then checks the columns and like it's just annoying to code is what I'm saying. So I'm just starting out with a single 2D image and the neurons are represented as 2D objects instead of 3D.
So you say this like the loops and all that. So do you already have a model now that's defined?
No, I mean I don't have a finished model. Like I said, I just like I guess if I had to guess, I'd say that the code for creating like the for generating the necessary information to run the model, that's well, without the dopamine system, by the way. Like just purely the basic stuff. That's like 50% done, maybe. Um, yeah.
Do you have it attached to a physical presentation?
I mean, yeah, I mean, I stopped at the step where you connect the two layers. Like, and that's where I decided that this is just dumb to do this by myself, or in general, it's just not kind of what I want to be doing. But yeah, that's the thing. That's the thing I stopped at. But yeah, the connections represent physical space, or mimic it, you could say.
So we could say that this is what we are facing right now. To construct the learning model in a way that
Yeah,
best mix complex
yeah.
structure of the
Honestly,
human
I'll
brain.
just tell you, I don't think like it just got too frustrating for me to do it on my own. So I wouldn't recommend that you try this on your own. But like if you watch my video to the end, you'll see that like at the end, I haven't published the video yet because I still made some final changes, and I'll publish it this evening or tomorrow morning. But
That's
in the end,
fascinating.
there's like a disclaimer of like there's like a disclaimer of here are a few projects that you can join if you want to work on it, and one of them is this. So who knows? Maybe we'll have people in a few weeks or so or a few months like that are willing to work with us on this. It's like I'm just telling you, I would not work on this alone, no matter what.
You think you'll publish the video to a large audience and gather traction?
No, I have zero subscribers. Yeah, that's no. This is my first one. Like I'm just starting out doing this. Um,
Yes.
so like I don't know what to expect, but well, I have this naive idea that if I just do a very, very good job with the videos, that I'll probably get viewers. But we'll see.
Obviously, there's a lot of amazing work in it. Been very engaged.
A lot of what?
I mean, obviously, you have put a lot of work in it and research, and I've been engaged
Oh yeah,
throughout.
Jesus Christ, dude. You don't even
Uh,
yeah. It's kind of absurd how much work went into that. But
I
hey,
appreciate it.
I also hey, I had a fucking good time doing it anyway, even though it was also hard as hell.
Mhm.
So,
Yeah.
I mean, yeah, that's the thing. It's like making the videos is insanely fun for me, or insanely engaging at least. And writing the machine learning model by myself was the opposite of enjoyable and engaging. So it's just, yeah,
Perhaps
it's
because
kind
it
of
is
how I
more,
decided to do this instead.
maybe because it's more abstract. Just way to.
I have no idea. That's possible.
Mhm.
That's possible, but I think it's also to a large degree that I kind of think that technology and better technology isn't what the world needs most right now. I mean, obviously, it would make like better technology can always make things better, obviously, but it doesn't seem like the thing that's most necessary right now. And I mean, you'll just see if you keep watching the video. There's so many goddamn things I've researched that where I just kind of had to get it out there, basically.
I'm more excited now to continue it.
Yeah, hey, everyone I've talked to so far found the second half of the video way more, like they liked both halves, but they like everyone I've talked to found the second halves way more interesting. But that's just because it
So,
like builds up on the things from the first half anyway. But yeah, I hope you'll see it the same way as them.
it's a conscious division, or it's just an observed.
No. Like none of that. Not at all. I guess it's like this is all a pure like a lot of the video is a pure accident. Like for example, in like 1 hour in, there's a part of the video where I'm talking about something, and in the background there's a clip from Death Stranding playing, like a cutscene from Death Stranding. Um, and just by pure, like I recorded the vocals way before I even got the idea of adding the Death Stranding footage in the background. But like the points I'm making are lining up extremely well with the video. But it was just like there wasn't a plan at all. It's just something that kind of happened, basically. Um, yeah, kind of weird, but you'll see. I just hope you like the video when you watch the rest of it.
I definitely have been just
Yeah.
going through all of the concept and really enthusiastic overall of this project once again.
Yeah. What do you think about it in general? Like, how far have you gotten so far?
So, I still need to solidify the concept itself and how it relates to what I already know from my limited knowledge of, let's say,
Oh yeah,
machine learning
yeah. That's a pretty important part.
and the human brain. I wanted to ask you, let's call them more fundamental, I guess basic questions,
Yeah, sure.
but the approach we're trying. So uh, let's
Yeah.
get at the root of it, since you are pretty open for discussions. So it is called artificial biological
Mhm.
general intelligence. So I'd like you to summarize
Yeah.
to me what is the project about and how it relates to other machine learning models. So I assume that it's
To what
like
machine learning models?
machine learning models in general, or the
Oh yeah, in general. Okay,
or
sure.
the mainstream way of doing machine learning. So
Oh yeah. Oh, yeah. I love doing that. So
the obvious
basically,
thing.
because
I mean, the obvious thing is that it is called artificial biological general intelligence. So it is a fundamentally, I guess, or a significantly different way of conducting machine learning.
well, okay, yeah, I always loved explaining how it's different from the mainstream because, like, I remember, like, I started out researching neurobiology when I was 15 for completely different reasons. But
Oh,
like back then, like when I was 15, I thought I had to genetically engineer humans to not be selfish, so I had to research neurobiology for that. Like, uh,
uh,
and then after 3 years, it turned out that that's not at all how selfishness works, and it's basically zero genetic component, like very small genetic component to it. Unless you see brain size as a component, it's basically not a factor. Um, but anyway, um,
yeah.
yeah, so it's different. What I always got frustrated with when I looked at like when I learned how machine learning works, I always thought, why are they using this insanely primitive process where they're just replicating the neocortex and like they're just replicating glutamate neurons or excitatory neurons from the neocortex, and that's it. And they're replicating literally nothing else, even though there's so much stuff that you could theoretically replicate. Now, back then, I had no idea about things like electricity costs and performance costs. So I thought you could just replicate absolutely everything and it wouldn't be a problem at all. Um, which is, yeah, that's not exactly gonna happen ever. But, yeah, anyway, I thought that the imperative way of doing the reward system was just kind of silly if you wanted to do anything large scale because of because of what I explained, because the human reward systems uh, are so unbelievably good. Like the self-correcting mechanisms, the prioritization systems, it's all so fucking incredibly well uh, organized. And
Yeah,
no matter what the context is, it can basically sort out the best option. Like, obviously things get complicated because we have such large brains and because we have prefrontal rational thinking and all that. But still, the mechanisms are just perfect. So I always thought, like, why not replicate that? Um, so I was always frustrated with why nobody was doing that. Um, yeah. So basically, I thought, yeah, look, AI is never going to be like humans if you just keep doing it this way, where you just decide from the outside looking in what kind of reward system to give it and whatnot, and when to strengthen its connections from the, like, as a person from the outside in, instead of having a, like, organically developing system, basically. That's the entire idea.
my intuition of the differences in these two approaches. The way I see it now is that the mainstream machine learning paradigm, it is based on the gathering of humongous amounts of data, and that is not equivalent to
Yeah.
the way that us humans learn and go on about in our lives. So I'd like to see how we could simulate the kinds of ways in which human brain operates, and we hope that we could
Yeah.
transfer the efficiency of the human brain into these
Yeah. I
systems.
mean, that's a very interesting way of putting it. Remember what I said about, like, someone tried recreating a novelty reward system in a machine learning model, and it ended up just looking at, like, TV static, essentially, like flickering black and white pixels was what it was most interested in. Um, that that shows a failure of creating layers of abstraction in the cortex. So a human wouldn't see a flickering TV screen as novelty, even though the pixels are changing constantly and in an unpredictable way, because it gets classified as a higher order concept, which is essentially random useless pixels. That's roughly the concept, or something not worth looking at. So you have separate systems based on different emotions, basically, and different emotional, like, different paths of action, you could also say. Um, and yeah, I believe that that is the key to creating higher order abstraction. Probably. It could also be that they just coded the whole thing badly, and just a dopamine system by itself, if you ignore the problem that it doesn't have a cortisol system, like, maybe it would have been fine. Like, I don't know. I didn't look at the study in such a large amount of detail. Um,
So
but yeah, either way, you get what I mean.
let's investigate this further. So how do you see that our model, the artificial biological general intelligence, would behave and react to such a situation? So we've deemed that looking at just the flickering screen somehow not very fruitful, or an action that
Well,
is deemed very intelligent. So
yeah.
what would an R model that's or replicates more of the characteristics of the human brain behave like? How would it
Well,
be
here's
different?
an example. It would be kind of like, how do you put it? It's kind of, it's not accurate to say that it would be kind of like a 2-year-old child or something, because we have very specific um, nurturing systems. Like, both parents have very specific nurturing systems for 2-year-olds. Like, I don't know. parents will instinctively speak at a level that is slightly above what their child already understands automatically. That the same advantage, like a machine learning model will never have the same developmental advantage, for example. Um, but what I would predict it would do, let's say it's during the learning process, for example, if it's getting if the systems coded are all coded properly, what it would, for example, do is if you're standing, like if you're handing someone something, it would instinctively look at that. It would look at you handing that person something because that would be the most novel thing it would see. Or if what's it called? If you're running really fast, and you usually don't run really fast, it would either have a significant cortisol response because its inputs are extremely unpredictable all of a sudden, or potentially also, because these things have to be calibrated through hard coding. That's the problem. Like you can easily get some of these factors wrong and it will break the whole system. Um, I'll get into that afterwards. But basically, because it would have a fovea, you would be able to notice what it looks at. And if it looks at things where you can kind of infer, like, yeah, it makes sense that it would look at this. It hasn't seen this before, or this thing looks different from what it's seen so far. Um, then you would basically know that it's working more or less correctly. And you would also, one other thing is you could, for example, have some sort of tracking system where it just every second or so it takes a snapshot of the relative neural activity, and you could compare like, okay, in this situation where I would have predicted high dopamine activity, was there actually high dopamine activity? Um, yeah, that's what I'm predicting for the learning process anyway.
Also, another aspect to it. So if we look at humans, even if we come across something novel, we get to a point like we would be interested in it, but that novelty and interest would eventually fade. Like we get habituated to the object that we desired.
Yeah.
So I think that's also
Yeah.
one of the differences, that like the machine you talked about, it's continuously looking at the flickering screen, didn't get bored or anything. It's not similar to humans. So how do we
Yeah,
define it?
because there was no learning processes. So, oh yeah, right. Okay, yeah, okay. Remember how I said, yeah, if they coded the thing badly, then maybe that's what fucked up the whole dopamine system replication. That might be exactly what it was, because it's like they replicated the novelty-seeking behavior, but they didn't replicate the learning behavior. I think, yeah, no, they didn't replicate the learning behavior. That's their Jesus Christ. But yeah, the mechanism of dopamine is to convert unfamiliar and unknown into familiar and known. It's like that's the mechanism. Can't just do half the mechanism and expect things to work.
So, like if we look at it technically, so we say it's a flickering screen, and in fact, there are a lot of things that we could say it's learning, because there is randomness that's being generated. While I guess maybe a more machine that can distinguish these kinds of small differences would be more interested in it than us, who I guess are not easily captivated by such randomness.
Well, this is a question of abstraction, right? It's like, in theory, a a rock is infinitely interesting if you decide that every single atom inside is important. And if you don't decide that, then it's just a single object, and you can treat it as a single object. But it is your cortex that extracts the redundancy inside of the rock and sees it as a single object that can be thrown and whatnot. So essentially, through the learning process, you get rid of redundancy or redundant information. I mean, that's what the whole cognition process is. It's just about creating those concepts to begin with, I think. Um, it's like
Amazing.
the dopamine system creates. Okay, let's take the screen example. Let's take the screen example.
Hmm.
Initially, it'll be interesting or whatever. If it's okay, let's say it's an infant, right? It knows nothing, and you just start out with a machine learning model with the right dopamine system and whatnot, and it knows nothing, right? So obviously everything it sees will be interesting. If not, if assuming that it's not stress inducing. And this is another problem because human infants have another advantage here. Because human infants always have an instant hypothetical source of stress relief, which is their mother. Like being close to their mother is like literally an analgesic or a pain inhibitor slash opiate kind of thing. Um, and with a machine learning model, it's not really. I don't know how you'd replicate that exactly, if it's even possible. But basically, because everything is unfamiliar, it means that everything is either interesting or scary. Um, and so let's say you look at the AI system looks at a static flickering screen. Um, if there was no learning process, it would look at that forever, or it would look at anything forever that doesn't trigger the cortisol stress system, right? If there's no learning process. But if there is a learning process, that means that because of dopaminial reward because of the dopaminial reward mechanism, the neurons that react when looking at this screen, those that react the most anyway, it's like the more it. Oh, I should mention something. Objects like any objects that are distinguishable through the eye and by touching them. Like, I don't know, that's what infants do, right? They pick up everything and touch everything and put everything in their mouths because that's where they have the most nerves in the beginning of their lives, right?
Yeah.
It's like simple object detection, basically. So objects exist as discrete units in your brain, completely regardless of whether you know what they are or not. Just because edges and shadows and that sort of thing. Like you detect objects anyway.
Yeah, interesting. Yes.
That's a very important thing. Yeah. So essentially, once the object, so the source of diffusivity is associated with the object that's causing the diffusivity. So the unfamiliar object already exists as a classified thing. So the unfamiliar object is put in the prioritization slash targeting system so that you go towards it and explore it more. Like you want more inputs from the unfamiliar interesting thing because the unfamiliar interesting thing is generating positive emotion. So that's the simple reward part. And then by getting more and more inputs from this unfamiliar object, essentially, these inputs that you're getting now get assigned to this object that you're seeing. And the problem is, I don't know exactly how this is, if there is even a particular genetic component to detecting objects and classifying them, or if it just happens anyway without us doing any hard coding, because that's what neural networks do, right? They extract the the larger order things. Like if you put a black, like I don't know, if you have a camera with a machine learning model, and it's looking at a white wall, and you put a like black object in the middle of the screen, that will be detected by the neural network inherently. There's no way to make the neural network not detect it, because that's the mechanism of cognition, right? The edges are detected, and then higher order neurons react to the commonality of the edges, and now it's an object, no matter what. And maybe that object corresponds to something like some existing concept, or maybe not, but it's already classified as an object, just because it's distinct inputs.
That's illuminating.
So
Yeah.
yeah, so you explore the object. That's the point.
That's as you've said. it could be already embedded in cognition. It's the detection of objects. And now if I try to
I
connect the
think it's
dots,
inherent. I think there's no way to design a neural network without that. Like, I don't think there's any particular system for object detection because there's no way to make neural networks not detect objects.
and so if I try to connect the dots, is that we're trying to make the system generate a reward for itself in
Yeah.
terms of
Yeah.
the
And the
dopamine.
reward creates familiarity. The reward creates a conclusion, and a conclusion is essentially just a distinct group of neurons that react to a particular input. It's like you don't remember most things that you do every day. You just forget almost everything because almost nothing is very important.
Yeah, true. Yeah.
Like, I don't know, if I ask you what you had right behind yourself, or like name all the objects that you had in your vicinity exactly 2 hours ago. It's like nobody would know the answer to that
Yeah.
because it's like
There's too much
so essentially
superfluous
it's like
information, right?
the short-term memory. Yeah, yeah. That's the whole point of cognition, is to sort out the useless information. But basically, let me get this right. Just 1 second.
Sure, take your time.
Yeah. Yes. Okay. I think I got it. No, wait, what exactly? What was that? What exactly were we talking about a minute ago?
We're talking about cognition and detection of objects.
Useless information gets sorted out,
Useless
and
information gets sorted out, yes.
objects that are unfamiliar get exposed. Oh, okay, I got it. So you always have your short-term working memory. Like, I don't know. I tested this a bunch, actually, because I was trying to figure out how to incorporate this into the neural network. If you, okay, let's say you look. I was looking at a table, right? I was in a table with like a bunch of other people working on robotics. So I was looking at another person's table, which was important because I didn't know this guy's table. And I just looked, trying, like doing everything I could not to focus on anything else. I just looked at a random part of the table without looking at any of the other objects, right? Then I closed my eyes, turned my head away, like more than 90 degrees, and then I tried reaching, and then I tried remembering what was there. And I remembered, like, okay, there was an object here that resembled, like, had this rough shape. And then I tried reaching for the object without opening my eyes, and I would always get it right. Like, very, very accurately. Even if the object I was thinking of, like, I don't know, was some circuit board or whatever, often it didn't look anything like what I had pictured in my mind, but I still knew the object was there. I didn't know the details because I didn't focus on it, so it was just, slotted into some conclusion that was inaccurate, but it was slotted into something because it has to be slotted into something. But basically, you have your short-term working memory, which keeps track of everything around you, kind of in a vector space environment, where it constantly tracks your head movement and your nerve, arm, leg movement, all that. And it essentially that's what keeps track of everything that's going on in the moment, and it has, I don't remember, like, its duration length. It's something like a couple minutes as far as I know. And for something to be transferred from short-term memory to long-term memory, it has to generate positive emotion in one way or another. And so, for example, some random object that you're tracking and that looks interesting, you explore that, and then this particular object gets made into a concept. So you take the object, and now because you explored it, it gets turned into a conclusion slash concept, which is just basically a group of neurons, like a bunch of different inputs. Like, let's say a child takes a Lego brick and he's like, what the fuck is this? And he goes towards it and picks it up, and he's like, okay, this feels kind of hard and whatever. Sorry. And he picks it up, He can feel kind of the shape of it, and then he puts it in his mouth, obviously, because kids always do that. So it knows kind of what it feels like in every way. Like it gets as much input of the interesting source as possible, because then the concept is created, and the concept has all the associated inputs. The shape, like what noise it makes when it falls down, like how shiny it is, how far you can throw it, everything. Um,
Yeah.
and because you have all those different inputs, that's why you have a functioning concept. That's precisely the mechanism. If you just had some of the input and you didn't explore it, then it wouldn't be a functioning concept. It would just be any given object with zero abstraction capacity.
Yeah, and in
Yeah,
this
that's what I really needed to get across.
yeah, in this process of exploring objects out there in the world and gathering as much about as much information about their characteristics as possible, so that the all of the information surrounding them gets our brains, then the learning happens. It's like we have learned
Yeah,
this class of
yeah,
whatever object.
precisely. And then you've learned it, and now you have a conclusion. And it's like, you can think of it this way. It's like the conclusion absorbs diffusivity because it inhibits everything else in the prefrontal cortex, for example. You know, like again, the letter A, if you look at an object and it gets classified as an A, then the neurons in your cortex that respond to A, or the A neurons, let's say, they inhibit the EXYZ neurons. They inhibit all the other letters because because you have the conclusion of A. And the conclusion of A inhibits all the other conclusions because that's what a conclusion is. So it's like yeah, so you can think of it this way. Unfamiliarity inherently creates diffusivity. Exploring unfamiliarity inherently creates a concept, and concepts inherently absorb slash minimize or mitigate diffusivity. That's like the whole circle, you could say.
These sentences are definitely worthy to be noted and further expanded on.
Yeah, and recorded.
Yeah,
Yeah, it's good I got that idea.
yeah, thankfully. But, let's rewind a bit to where. So we're talking about this the flickering screen, and you mentioned.
Yep.
I wanted to stop you on that on a point you mentioned that I didn't quite understand, which is the how it relates to the whole system and so on. The cortisol system. You mentioned something about it.
Oh, okay. Yeah.
So
I got it. Got
what's
it.
its
Yeah.
significance? And
So the
sorry.
cortisol, yeah, the significant is this. A concept and inputs. Okay, so first of all, in the biological real world, there's the problem of threat. And if you can't put something into your existing conclusion, it could be a threat. So it makes sense to have a cortisol system that makes you stay the hell away from the things that scare you. Like unfamiliar things scare you inherently. That's the mechanism, right?
So
So,
I guess
so
to simplify it for my brain, it's like the dichotomy between things you seek out, which are positive, which you gain rewards from, and things that you avoid, which could hurt you, which could negatively affect you. Am I arriving in
yeah,
the
basically.
correct space?
Yeah, but it's not just that. That's the cool thing. It's not just that because it's like in a well-calibrated brain, and it might be that this is completely inherent, but I don't know because mentally ill people mentally disabled people do exist. But in a well-calibrated brain, whatever the preconditions are, in a well-calibrated brain, the things that the dopamineal system points you to are automatically things that can reasonably be put into known territory by exploration. So, for example, let's say that you're a completely uneducated, like, I don't know, let's say you have an IQ of 50 and you are illiterate and all like just very, very low intelligence and zero education. And let's say you find like neurobiology lectures completely interesting, even though you don't understand any of it and you get nothing out of it because you comprehend none of it. It's like now you're wasting your attention on something that doesn't benefit you in any way because you can't learn anything from it because the inputs are so far away from your existing neural structure that it can't be translated, like it's too far away. Um, so it can't be readily, your existing neural structure can't be gradually changed in order to accommodate the new information. The distance is too large. So even if it's not scary, it makes sense to have a cortisol system or some other repulsive system towards information that is too unfamiliar. So it's like,
Mm.
yeah, there's the real physical threat aspect in biological organisms, but it's also a purely neurological thing
Oh,
in terms of just whether you can actually learn it or not.
interesting. Yes. So this is kind of say way to or prevent let's call it incessant learning. It's like are kinds of limitations what you could learn.
Yeah. Yeah. Yeah, so there are real limitations to what you can learn because what you learn inherently has to be based on things you already know to some extent.
So could we say that this process could guide the system towards learning things just so that it's level starting from the basics. It's
Yeah, that's the whole point. Yeah, the dopamine exploration process guides the system towards the inputs that it can most readily learn. That's exactly the point.
that's amazing. Yeah, like because if we take it analogously to humans, this is how we do it. Obviously, like how children learn, not just throw like science textbooks at them that are at college levels. Bit of from
Yeah, the fact that the kids aren't interested in that shows you directly that it's not what you should be trying to teach them.
yeah.
Like that's directly, yeah,
So
it's the most perfect indicator possible. And this is, this is exactly why imperative machine learning pisses me off so much because it's the same fallacy. The idea that that you yourself can decide authoritatively what's the best input for the machine learning model instead of creating a system where it can itself respond to inputs and decide what's the most readily learnable thing.
yeah, fascinating. Yes. So this is an inhibitory process to limit the.
Inhibitory?
I
How?
mean, inhibiting the unstoppable learning. So it's to use it with more structure, let's say, or more.
Oh, you mean the cortisol
Yeah,
system is like an inhibitor
yeah.
to unstoppable learning?
It makes the learning process even a more fruitful way. Actually, gain knowledge and
Yeah, I
understanding.
mean, it's what makes learning itself possible. Because otherwise, yeah, that's the thing. With only the dopamine system and no cortisol system, you would just automatically search out the most incomprehensible thing you can possibly find. Because the most incomprehensible thing is what would cause you the most signal diffusivity.
Yeah, I see it now.
So it really, yeah, so even though a machine learning system doesn't have any threats or whatever, it still needs a stress system and a, you know, repulsive system.
Yeah. So could we say that this is what's at play when we watch a static screen? It's like we're not getting much, I guess, information out of it. So there's
Yeah, we're getting no information out of it because there's nothing to learn from it, basically. There's nothing unfamiliar about random pixels on a screen. It's like you know what I mean, if you've never seen a screen in your life before, it'll be interesting as hell, obviously. Like,
yeah.
I mean, I'm sure you can just think of that. Imagine you had never seen a screen in your life and suddenly you're seeing a flickering TV. It's like, what the hell is that? You're gonna go explore that. But to us humans living in first world Western countries, let's say, or whatever, we know exactly what a screen is. So, I mean, when I was a small child, I would stare at the flickering screen, actually. Um, but not for very long. I did that, first few times I saw a flickering screen, and then I just kind of got bored with it. It's, because then now I understand what that is.
I'm reminded by that scene in American Beauty, the film, where
I haven't seen that, unfortunately.
yeah, it brings to mind a similar kind of practice.
Can you describe
Yeah,
what
yeah,
it is?
one of the characters was really interested, I guess, in what we call them, like randomly interesting. It's like a force of nature, some kind of thing that happens in nature that they get really captivated by. Keep on watching. I'll send you the link of that clip.
Hmm. Okay, sure. Yeah.
Just like watching a flickering screen. I think it is somehow really interesting.
Yeah.
Yeah, anyway, so let's see, where are we at now? So we cleared out the. I've gotten better understanding of connections between the dopamine system and the cortisol system, and how they facilitate learning in terms of their interactions. And let's say what else? So what else is there in this space in terms of what we're trying to replicate? What are the other ingredients?
Well, if you want, I can tell you about the serotonin system, which is, the kind of self-empowering slash status slash power over existence circuitry.
There's that, and what about the rational, the seat of rationality? Of the prefrontal cortex.
Oh, rationality. Oh, that's the thing. Rationality is really nothing special in comparison to these fundamental mechanisms. Rationality is just what happens when you take, like, what's the nature of a conclusion again, right? It's once the relevant, you know, you first explore an unfamiliar thing, now it's a concept, and now it's like it's either this concept or it's something else. And if it is this concept, then other things are inhibited, right? That's fundamentally what a conclusion is, and that's what the cortex exists for. That's the only role the cortex has, is to create conclusions based on different kinds of emotions, obviously, but still, the point is to create conclusions. Um, because conclusions is what leads to action, and action, like movement of muscles, that's why the brain exists. Um, and yeah, so let me think. What was the initial question?
So would that be built on later on? Because the way I see it is that it's a learning system. It's on exploring of all things throughout the world.
Oh yeah, right. You asked me what the reason for rationality is, like how you program in that, or what the source of it is. Now I remember.
Yeah. I would assume that trying to arrive at, say, kind of.
Yeah, exactly. Okay, now I'm back on track. Okay. Let me try to get that. Okay, so essentially what happened with humans is that they just took you could say that the evolutionary process took this relatively simple mechanism of the cortex dynamically creating concepts based on positive emotions and just took it insanely far, which you can see just by the sheer volume of the cortex in general, and especially the prefrontal cortex. And the ratio does seem to matter because the total size of the brain has actually shrank in the last few 10,000 years of human evolution. And the only explanation I've ever found that seems even slightly reasonable for this is that the brain areas or regions that disappeared or shrank significantly were the ones for immediate reactive aggression, let's say. So it would essentially be parts of the cortex that are less inhibitory. Um, because, less inhibition means you more easily reach the threshold for action, right? So, so basically, you take the mechanism of inhibitory signals, or you could say like lateral um, inhibitory signals. So like what I mean with lateral is you have one concept inhibiting concepts that are of the same nature or in the same general level of abstraction. Like the letter A inhibits the other letters when it comes to a particular object that's being considered because it can only be one letter, right? So you take that mechanism of a conclusion, let's say, and you take it extremely far, and then you reach extreme levels of complexity. That's what I think. That's what rationality seems to be. Um, and because the rational, prefrontal cortex, the inhibitory areas, because they're so disproportionately large, but also disproportionately large in relation to the rest of the brain, it's like they have more control in, purely in terms of neural volume, right? Because that ultimately does matter very significantly. Like the sheer amount of electrical signals does matter when it comes to weighing different options, let's say, that are being weighed in the thought process against each other. So essentially, it seems like, yeah, that's what rationality basically is. It's the concept of conclusions slash mutually exclusive thinking taken to an incredible extreme.
And would you
Probably.
say that it could be an extrapolation of this simpler process of learning to
Yeah, I think that's
less
exactly what it
less
is.
complex systems? They
Because there's no fundamental mechanism that exists.
uh, less complex systems grow to of this the complexity,
Yeah.
developing rational thoughts.
Yeah, and that's the thing, that's what makes the cortex special. It's like, for example, if you have one liver from a mouse, let's say, and a liver from a human, um, the liver of the human will be, I don't know how much, like let's say 100 times larger or 1,000 times larger. I don't know. It's not 100 or 1,000 times more biologically complex. But with the cortex, because the complexity doesn't come from the biology directly, and it doesn't come directly from the biochemistry, it instead comes from how the neurons are arranged. You can just increase the quantity of neurons and automatically get way more complexity because you're just stacking abstraction on top of abstraction on top of abstraction perpetually. Like, I don't know, if you replace two random chunks in your liver with each other, um, as far as I know, the liver would just keep going as usual as long as you didn't destroy any blood vessels. It's because the liver just recovers, partially because the liver is just very good at recovering from damage, but also just because it's the same, like they're the same biological roles being fulfilled by both random chunks of the liver. And in the brain, that's not the case at all, or in the cortex at least.
There's the stacking of abstractions, as you've called it.
Yeah, yeah, precisely. And it's like, and I would imagine that if you just increased the level of inhibition and abstraction even more, you would just get more like I think inhibition and abstraction and intelligence are impossible to separate in practice.
Inhibition and abstraction and intelligence.
Because like
What
yeah.
are
Yeah, I mean
we?
that's what intelligence is.
What are
It's
we?
like you extract all the useless shit better than everyone else.
So yeah, what are we being inhibited from? Or are we inhibiting ourselves?
Well, it's like ideas inhibit each other. So it's like, well, what are you gonna do? Let's say you're thinking of, okay, what am I gonna do today? Like, okay, you wake up and you have some habit based on positive emotion, like some breakfast routine, I don't know, just something you do every morning, and because that produces positive emotion, and it's extremely familiar, which really are interchangeable concepts when you're talking about the cortex, but you have some routine and you just do it, and then you don't use your prefrontal cortex much because the there's just one conclusion that you're running with, basically. There's no there's no thought process or no abstract thought process going on. And when you're in a situation where you're not sure what to let me just say. So essentially your morning routine, let's say, is a conclusion. It's a gigantic and complicated one, but it's just fundamentally it's indistinguishable neurologically from other conclusions from what I can tell. Because like there's no biochemical mechanism whatsoever in the entire prefrontal cortex or ACC that's meaningfully different from what you'd find in any other part of the cortex. Like it's just different levels of like higher percentage of inhibitory neurons. Anyway, so if you're in a situation where you're thinking of what to do when you're not sure, then you have to weigh, like what are you doing when you're thinking of that, right? You're thinking of different conclusions and weighing them against each other and combining them together. Like let's say, I don't know, okay, am I going to take the bus or the train today? Because I don't know, my car broke down. Then you think of that, and then you like think of the pattern of action or the concept of taking the train and everything that's associated with that. And by thinking of that as a, I don't know, like how much do I have to pay? How long is it going to take? All those factors, you combine those together into, like in your prefrontal cortex and working memory, you combine those together, and also in your long-term memory, but whatever. You combine those things, like all the things you associate and you can think of when it comes to taking the train, that's now a conclusion, at least in the short-term memory, and you do the same thing for taking the bus, right? So you just form very, very complex conclusions, basically, based on other conclusions, based on other conclusions. But you get the point. And then you're weighing them against each other. And what are you doing when you're weighing two ideas against each other? You're essentially deciding which group of neurons should inhibit, like you have two options, which are in your brain represented by two different neural structures. And in the prefrontal, God damn it, there's a clock ringing. Whatever, I'll just keep talking. You're essentially deciding, okay, should neuron group A inhibit neuron group B and thus be the only conclusion left? Or should neuron group B, which represents the bus, let's say, should that inhibit the train neuron group and then the bus neuron group, taking the bus neuron group is the only conclusion left? It's the same exact mechanism as when you're subconsciously determining whether this object is a letter A or a letter F or whatever. And once you reach a conclusion, the conclusion inhibits all the other potential candidates. So that's rational thinking.
Inhibiting all of the different options we could take, we could arrive at a conclusion that
Yeah,
we deem as
yeah, basically.
beneficial or applicable or context.
Yeah. There's obviously going to be more to it, I think. Like but the fundamental mechanism is this pretty clearly. Because there are things I just didn't mention. Like, how exactly does it happen that you combine for example, how does it happen that you associate, like how do you connect the neurons that encode the paying money to take the train? How do you connect that together with the idea you have of maybe should I take the train? Well, okay, I think. Oh, wait, it's the same process again. Like when you're putting a Lego brick in your mouth. It's the same process where you're just getting more and more different inputs that are associated with some object that you're considering. It's just that, except for instead of physically getting closer to the object you're exploring in the outside world, you're instead just directing your attention towards 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 the unknown idea in your cortex.
And
I'd say that's pretty much what's special about rationality, is that instead of your conclusions and your actions being purely in terms of moving your muscles, you can decide to direct your attention towards something. And your attention is just neuron concentration, like neural signal concentration levels. Like that's a pretty goddamn crazy thing if you think about it.
I guess we engage in more interoception or exploring the ideas inwardly rather than purely
Yeah, it's
engage with
like
the outside
it's
world.
like you can explore your inside world in the same way that you explore the outside world. Essentially, like when you're exploring the outside world, it's that you're telling your, you know, as from what everything I've seen, the thalamus is the part of the brain where conscious thinking happens, but that's kind of, I think that's more of a problem with measuring it because the thalamus doesn't really have much internal stuff going on. Um, but if you do like partial anesthesia trials, what you always find is that people only consciously notice things or remember things when it wasn't their thalamus that was anesthetized. But anyway, I think it's obvious in some way that you can somehow direct your conscious attention towards whatever concepts you want in your cortex, weirdly enough. Like, I don't know, when you're trying to, let's say, remember something that you can't really remember, and then you're trying to think of things that are similar to it. It's the same kind of exploration process as when you're, like, let's say you're physically looking for your keys and you're going through your house and you're trying to look for all the places where you might usually put them or whatever. And you compare that to the process of where the hell did I put my keys? And then you try to think of it. What did I do before I took my keys today? And you're exploring like it's the same exploration process. It's just that in one setting, you're using your muscles to move throughout your house, and in the other, you're using like your rational attention in order to move through your subconscious, which is like
Interesting, right?
fundamentally it's the same mechanism because it's just that a conclusion ends up sending a signal somewhere else in your nervous system. It's just that for all animals, and like the fundamental usual pattern is just that the brain sends a signal to the muscles or to the nerves controlling muscles, and that's the direction of attention. But with rational inhibitory thought, it seems to be possible to do the same thing but in the other direction. So you can put your attention towards somewhere else in your brain. Like that's
Yeah,
yeah.
that's fascinating.
I would say that that's probably the most difficult mechanism to explain. And how, like, again, I think that trying to consciously replicate this, like, okay, what's the mechanism and how do we hard code this? I think that would be a mistake because I think, like I said, it's the same fundamental mechanism as any other as any other conclusion. It's just that the signal gets sent to the somewhere else in the brain instead of getting sent to nerves.
Mm.
It's just hard to it's really hard to wrap my head around it even now where I'm like explaining it in theory.
So the way I see it from your explanations and what I understand, that you are more on the side of letting the models create an artificial biological general intelligence, let them learn and develop naturally without much hard coding and them. And
Well, you have to be very specific about what you hard code. It's like what you want to hard code are processes. You don't want to hard code anything specific. You want to hard code the most abstract things.
so we
Like what the
also
dopamine system responds to is super abstract, right? That's what you want to hard code.
And to add to this, so we also don't want to hard code any specific interests, you think, in terms of what it would actually...
Not in the beginning. If you want to use it for something, you have to, I think.
So it becomes...
Unless you want to get into the whole territory of... Well, hey, there is one thing you could do, which is... Okay, so let's say that the dopamine system decides that something is interesting or worth getting to, and there's an obstacle. Then what? Like, then you get frustration and anger, and that's the response. But let's say you get rid of that obstacle. Like, that creates a positive emotion, but that's not dopamine, that's serotonin. So the overcoming of obstacles is the serotonin system. And again, you see how the dopamine system depends on the cortisol system, and you can't have a dopamine system without cortisol. The same thing, the same relationship exists between serotonin and dopamine. Because if you don't have a dopamine system to simply prioritize things, I mean, there are other aspects like simple endorphins and opiates that also are positive emotion systems. But either way, if something is put in your targeting system and there's an obstacle and you get rid of the obstacle, that's the serotonin system. And that's essentially, you know how like like the Jordan Peterson example, like lobsters have dominance fights, and if they lose, they show signs of depression, basically. And if you give them antidepressants, you know, the same ones that humans take, they'll go and fight the other lobsters again, basically. So it's like, that's the status system. Or estimation of your own power.
And
right?
And
what
would be the weakness?
You could replicate that digitally too, in theory. I don't know how exactly, but you know, this is roughly the mechanism. And then you would all of a sudden have an AI that's trying to maximize its own power over the outside world, which, well, I mean, you could do that too instead of trying to hard code it to like sort through Excel spreadsheets.
So,
but I think it's probably good to just try to get the dopamine system working first. So
in order for me to understand better, let's take this example of a system without a model without the serotonin system, and what would be its weakness? Because you mentioned that when it's faced with obstacles, that would be the serotonin system at play. That obstacle is removed. So, what if it didn't have the system? What would be the disadvantage or weakness?
Oh, that's very interesting, actually.
Yeah.
Let me think I didn't consider that at all. I haven't thought about that at all. I'm thinking that there has to be some sort of workaround here. I think probably that it just means that it has a lower it would seem like it has a lower attention span comparatively. Because obviously there was a time where, you know, brains existed and the dopamine system had evolved, but the serotonin system didn't evolve yet. That was a thing at some point.
In other biological...
Because, you know, they didn't evolve at the same time randomly. That's not how evolution happens. So, yeah, that's
yeah.
I haven't thought about that at all.
I'm glad I could bring something novel to the table here to ponder on.
Okay, dude, don't even worry about it. It's all, yeah, dude, that's really interesting. Yeah, let me think. What do you think that would do? Like, what do you think would happen if, let's say, we have this theoretically functioning AI system with a functioning dopamine system, and it encounters something it decides is interesting, and it encounters an obstacle. Like, what do you think would happen then?
So the obstacle, it's preventing it from reaching to object of its desire. That's the case with our example.
Yeah.
So,
yep.
So we can imagine that a regular human who is seeking something, they would try to eliminate this obstacle. Because
Yeah, like simple aggression, like when you get frustrated with your computer or something, like you immediately get angry.
yes, and that anger, it should serve the AI model or the human to change their behavior in some way, in order to try to make their feelings better, or try to somehow change their situation. So,
Yeah,
yeah,
basically.
I guess I imagine there wasn't this sort of drive of changing how things are on the outside
Yeah.
world.
That is, God.
Yeah,
Yeah. So it's like you would have to. That's so interesting that it would actually be somehow necessary or helpful to encode some sort of, maybe not an aggression system, but some sort of,
so
I don't know, dude.
yeah,
Some sort of, I have no.
so the two states.
Like aggression system would be kind of difficult because the AI, like what exactly can it do? If it's just controlling a camera, what exactly can it do, right?
Well,
I think that's like that's such a crazy way of thinking of it because like let's say you encode some aggression system somehow and you replicate everything correctly, which I don't even know how exactly. It would probably be super simple because aggression is insanely like primitive, but um
yeah, but
like then it's like you would like it's like some thought experiment. Like imagine that your brain was like locked into a, like I don't know, like all your sensory systems would work, but you're all like it would be like if you were paralyzed from the neck down. Jesus Christ.
uh, but at least it doesn't have the emotions and frustration with it from its that particular state it's in.
Oh yeah, well if you encoded the frustration
Yeah.
aspect, um somehow, like you replicated that emotional system, um, but it wouldn't inherently be able to do anything, then like what it, Jesus Christ.
I mean,
I mean, okay, wait, let me think.
exploring the two options it has, it either tries to eliminate the obstacle that it's faced with, or simply
I think
retracts.
it's a very
It retracts, right? It just
I think I think it's very interesting to think maybe the like destruction slash aggression system, maybe that's just as fundamental as the dopamine system. Or no, it's more part of, no, it's part of the serotonin system inherently, I think. I mean, because it's the same mechanism, obviously, of obstacle destruction slash, somehow making the obstacle no longer be an obstacle, right? But I mean, yeah, it's like even in like normal human culture, like aggression slash destructive emotions and like self-empowerment and status pursuit, like those are even in our like human culture inextricably linked concepts. And the more you go to the primitive end of human culture, the more you see this like linking of those two concepts of status and aggression. That's so goddamn crazy. So basically, if you wanted to have a civilized AI, let's say, that you would have to somehow, because like like humans that live in, let's say, not very aggressive societies, we at some point learn to separate out the aggression and anger from the like that as a mode of action. We learn to separate that from the increasing of our own power. That gets separated somewhere. And how the hell would you teach an AI to separate that?
it's sort of that.
God.
Yeah, we're not getting status from aggressive displays anymore. As
Yeah,
yeah,
no.
like in,
I mean, there are societies where you do.
uh,
I mean, especially like okay, 200 years ago, I would say that's most societies on Earth where that's exactly true.
yeah, right.
Um,
But we've transformed, I
and
guess.
I mean, you even see this in like, yeah. I mean, I think a lot of people are extremely naive, like a lot of Western people are extremely naive about just how bad it can get and just how insanely primitive some cultures are. Like, I don't know. Like there's some quote, like the Maori, like the tribe in I think New Zealand. There's like some record of early encounters of the first colonialists, and basically they talked to some warrior for some tribe, and he basically just said, like after they were waging some war of conquest against another Maori tribe, and they basically said, um, "We slew every man, or like we slew every man in battle. Some of them tried to escape; those we killed. Um, the others were enslaved. Um, we took their women as prizes, as in accordance with our customs." Um, and then he says, I think, what was the rest? Yes, many died, but what of that? It was in accordance with our customs. Like this was most of human existence. Like 90% of humans who ever lived like
Yeah,
that.
this kind of information,
Right.
it's not much in favor of the noble savage, right? Belief that humans are.
Yeah, no, there's not a, yeah, okay, okay, dude, if you look at literally any statistics, the noble savage argument just stops being a thing. It's just every single time it's exactly the opposite. It's like, okay, 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 this is really interesting. You know how, like, the oxytocin system is the maternal love slash bonding hormone slash neurotransmitter, right? Um, but another role it has that people for some reason don't know about, and I just learned about this through another YouTuber's video, is that called Third Paradigm, who's really goddamn good. It has another role of outgroup hatred, like hating other people or hating outgroups. It's just as based on the oxytocin system as like loving your in-group, let's
And that's
say.
precisely what you mentioned in
Um,
your video. What do you do to people who
yeah, yeah,
hurt your
yeah,
loved
exactly,
ones?
exactly.
You rip
Yeah,
their guts apart. I remember that line.
yeah, yeah, people who hurt your loved ones. Like that's what love means. Like
Yes.
you can't separate those two
And
concepts, like even on a neurological level.
that was very
Um,
insightful.
but yeah, basically, yeah, but okay, so the thing is, if you have like a compassion-oriented philosophy, let's say, or worldview, which, for example, like most of like a lot of modern political movements or whatever are based primarily on compassion. Like I don't know, compassion for serial criminals because they're underprivileged or something. That sort of thing. Based like compassion-based beliefs. Um, what you wait, what's the point I'm even trying to make? Something about outgroup hatred. Um, Oh yeah. Oh, this wasn't what I wanted to talk about. Okay, yeah, now I got it. So basically, the noble savage idea exists. If you look at, for example, there are many Indian tribes where their internal organization was basically analogous to communism, like the ideal communism, where where there's no monetary system and people basically just share things. And in most hunter-gatherer, basically all hunter-gatherer societies, or no, not society, but tribes, every hunter-gatherer tribe in existence, basically, you have this same kind of social organization where it's like egalitarian to each according to his need, from each according to his ability. It's exactly that system, right? And it's based on compassion, right? I mean, this is why people are attracted to this sort of belief system, right? Because it resonates with the compassion side. But what you always see, also without exception, in those tribes, is that you see the internal communism sharing uh, system. But when dealing with other tribes, what you also see without exception is that they murder other tribes, without batting an eye. And it's like you murder all the other people and kill and you take their women as prizes and kill their offspring.
Yeah, so
It's
compassion is
like
not exclusive.
you don't get to separate one from the other.
Yeah,
Huh?
not exclusive. or containing
Yep.
different humans. Basically, your group, which you are compassionate with.
Yeah. Yeah, it's like the internal it's like because the internal cohesion of the tribe is based on oxytocin slash love slash compassion or whatever, um, it's impossible for that tribe not to be insanely violent against everybody else. Seemingly.
Yeah.
Because, like, I mean, have you seen it, like, statistics about, in with these Native American tribes, for example, I don't know of a single example of these, like, egalitarian tribes. I don't know a single example where the percentage of men who died in war wasn't in the double digits. And in Europe, during World War II, it was in the single digits for every country, except for the Soviet Union, but that's also because of the famine and all that. But you get the point. Like, even Europe, in the worst circumstance ever recorded, wasn't as bad as just regular warfare in these tribes.
Yeah. Yeah. There have been a lot of.
But it's so crazy how you can trace all that back to just the mechanism of the oxytocin system.
Yeah. There have been a lot of arguing against motion.
Huh?
Particularly Steven Pinker, who is the championing of this argument against nobleness.
You mean the noble savage argument, or
Yes,
what?
exactly. Because that's what he mostly expressed. How the conditions have increasingly been getting better. Civilization. It's the main crux of his argument.
Yeah, I mean, the thing is still, um, being in civil, the thing, I mean, it makes kind of perfect sense, but the less civilized you are, the more generally you experience positive emotions, seemingly.
So,
That's the,
could we say is that
because, there's no sources of anxiety, relatively speaking, in that sort of environment, or way less, because of the whole delayed reaction to anxiety thing that I talk about in the video.
yeah, I got to get to
So,
that.
you know, on a material objective level, things obviously get way better. But it also gets much more difficult to organize, so you have more sources of anxiety.
We could say that life without civilization is more spontaneous or closer to instinctive.
Well, yeah, basic. I mean, obviously.
Yeah.
That's what civilization is. It's prevention of spontaneity. In order, yeah, long-term delaying gratification, all that thing. That's all inherently tied up with the whole civilization slash masculinity or structure idea, basically.
That's so interesting. So,
It's also tied to rationality, which is again, if you look at, you remember the diagram from the video that I keep showing over and over, right? If you look at that, you can see the same thing again. The highest order concepts are at the closest to the top of the pyramid, let's say. And if you look at the brain or the cortex, the highest order concepts are the ones that are most anxiety ridden slash inhibition based. Just like how the most civilized environments are most prone to anxiety for the individual person. It's it's just the same pattern on all layers of existence, basically.
I got to keep on watching the video and see what sorts of conclusions they arrive at.
Oh
Because
yeah,
they're
but the graph I'm talking about is just the one that
yes,
you see from the very start. With the Indo-European definitions.
this one with femininity left and masculinity right. That
Yeah, femininity masculinity axis. That's the one. Like if you look at if you look at the masculinity part, it's like they're all pointing in the same direction, basically, the arrows, right?
so
And the higher up you get, of course, on this diagram, the more to the right you get, the closer you are to the top of the pyramid, and the less arrows there are, because inherently, the closer you are to a conclusion, the more inherently exclusionary the conclusion is, because that's what a conclusion is. And rationality is just conclusions taken to an extreme. So
So
yeah,
now as you're
so
explaining
the
it,
closer you get to the top, the more exclusion you have.
so the way you're explaining how this geometric shape also is a message or is of something you're trying to portray.
I'm sorry, what did you say?
So as you're saying that how the arrows point, there is meaning behind this geometric shape. Geometric shape.
Yeah. Like, I'm almost always thinking about that shape in one way or another. Like, I've gotten it so, because it represents so many different things. Like, just look at the arrows, right? At the bottom, you have, I mean, okay, compare, for example, if you look at the video, I thought kind of that this would be self-evident because I keep showing the same graph. But like just look at every single graph I'm making. It all mirrors the original diagram of the femininity masculinity axis in some way. Like the Darwinistic process is shown in the femininity graph, for example. Um, or you know how neural networks work is shown in the masculinity graph, like inherently. Um, like look at how the diagram where I show how the concept of A is created from lower order
Yeah,
concepts at 27 minutes
let me
40.
get to it.
Yeah, like it's the same fundamental idea.
They are
Um,
converging.
like that's why I used arrows in that one.
Converging to
Yeah,
a
like as you
conclusion.
get closer to like the higher order abstractions are based on lower order inputs.
Yeah, I see.
That's it's just like and it's not the case it's not exactly the case that I just tried replicating how neural networks look. It's just that when researching different things, I constantly kept seeing the same pattern and I just made a diagram of it and yeah, this is the pattern basically. And you can apply it like you can in theory I could in theory just have left only that diagram of the femininity masculinity thing up for the entire video and it would always be relevant to what I'm saying.
Yeah,
Um,
I
it would just be kind of boring, I
yeah,
think.
I think that's the main case against it. Because
Yeah. Or like if you go to 1 hour, 6 minutes, 33 seconds, you can also see like in a seemingly unrelated thing. It's again
we're
like
getting ahead.
it's just a pattern that exists everywhere.
Yeah, we're getting ahead. I don't want to spoil myself
But
here.
yeah, lower order gives lower order is a fun. Oh, you didn't finish it completely. Okay, never
Yeah,
mind.
I have
Um,
arrived at I think around 40 minutes.
okay. Oh yeah, that means the really good part is well,
Behind me.
you're getting there.
Obvious.
What did you say?
Uh, Nothing much. I was just trying to see where we're at right now. I mean, obviously, lots of interesting things to explore. So, so now you seem to be have multiple kinds of tests and skills, and you have this.
Yeah,
Yeah,
basically.
you have this method or authority.
Many different interests, you could
Yeah,
say.
yeah. What you're
Yeah.
trying to do is somehow making them all connect with each other or seeing the relations between these different aspects in
Yeah,
life.
because they indicate it's like if you can take all the disparate parts and connect them together, what you see is a more fundamental underlying structure. That's the whole point of the video, is to show what's the most fundamental thing of existence. What's the most fundamental aspect of existence? That's what the whole video is about. And I mean, it's not just that, because what's the most fundamental part of existence automatically, it's like it also in automatically gives you exactly the correct moral system.
Yeah,
If you understand
so
exactly what
this
existence,
is the theme.
you understand exactly what you should do with it, right?
I noticed that is the theme for what we're trying to build is somehow like starting from the simpler terms, ending on it, and we have this kind of confidence or wish that it would keep on revealing things and making things clear to us, or somehow that what we develop would be able to reach higher amounts of understanding and also help us arrive at doing better things or think at.
You're talking about the ABGI system now, or still the video?
I mean, in general, I'm talking about the theme or the process in which you
Oh yeah,
operate or the
yeah,
way
yeah,
you
yeah,
think
yeah.
about things, like simple
Oh
concepts.
yeah. I mean, look, what
It's
I can tell you specifically what it is. It's like what fundamentally drives me is that I can just, how do I put this? Um, Whenever I am confronted with what most people are doing and spending their lives with and whatnot, it always, well, it seems like something's missing in my own life. And that's basically, once I started working on these videos, all of a sudden I was feeling perfectly fine,
this
basically
video, hopefully
all
more
the
to come,
time.
right?
Except that sometimes I couldn't. Yeah, yeah, yeah. I'm not gonna stop this. It's like this is the gigantic foundational video, and the idea is that okay, this explains fundamentally what's important. And it's like so far, I mean, the video isn't public yet because I've made some modifications. I've added more visuals, basically. Um, but fundamentally, nobody that I've sent this to has disagreed with anything I've said at any point in the video. And given the fact that it's a 1 hour 40-minute video titled "The Point of Existence," I'd say that that's pretty good. But that's kind of ridiculous that nobody disagrees with anything.
but uh, but
Um,
but
but basically, it's like, okay,
to counter counter on that, maybe we shouldn't arrive at that conclusion right away that there are no objections. Perhaps because the other people who have watched it aren't on the same level of sophistication. Be
I
you,
mean, that's obviously
yeah,
something you
because
can think, but I don't know. I mean, this is why I mentioned in the video that I want everyone to focus on what I'm saying, like what kind of effect that has on their emotions, right? Because the rationality aspect is just not the most important part, even though it is extremely rationally sophisticated,
so
I mean, I don't think I should myself say that what I'm doing is rationally sophisticated. Like, I should leave the judging for others, but yeah, basically, I don't know. I'm not getting that impression.
yeah.
Um, I mean, the people I've sent this to, some of them I can tell they don't really care that much, and that's that. But there's some people where I can tell that this is having an effect on them, and they're,
Yeah,
they're responding to it in a way that makes me think that they get it in some way.
yeah, it's the I think it's the tendency for us who aren't so I guess let's say not knowledgeable about more complex topics and so on. It's easier for us to get swayed by talk that seems to us to have like a high level of work put into it and the like sophisticated arguments and so on because we sort of end up simplifying much of it or seeing it. Yeah.
Yeah, I mean, obviously that's necessary to a degree, and the only reason why I don't have to simplify I mean, okay, again, I don't want to talk myself up because I think that's just not that doesn't reinforce the right kind of habits. But it's like I've just had an insane amount of free time on my hands since I was 15 because I kept skipping school and did almost nothing for university for 2 years. Um, and then all I did was like learn how to code for a year, basically. And that's so like I've just had tons of free time, and that's basically all what there is to it. It's like you can't expect everyone to be like some genius of philosophy because people need to actually go do things.
Yeah,
Like
yeah, exactly.
um with their life, like have a life and get a job and that sort of thing. Um but I don't I feel
Uh,
like I'll see when I publish it,
yeah, I mean,
obviously, assuming that it will get any views, but I
it's just
think
something to keep in mind.
some parts of the video at least are explained, I think, in ways that are completely accessible.
Well,
Like especially in the beginning and the parts and where I'm like kind of making larger points about like
it's just that I'm
what the fundamental values of life
commenting
are.
on your conclusion, particularly as you said that uh, everyone who has watched it has not raised any objections, or they
Yeah.
had basically like a great reaction to it.
Yeah. Obviously people I've sent it to isn't a random sample. I get that.
Yeah, and they differ in terms of a level of understanding and so on. So uh, I guess
Yeah. But
yeah,
look, the thing is, I'm not trying to make this video like when I make no,
would
go on.
arrive basically at a better understanding of how your work resonates with time and for people with different types of
Yeah.
people and so on.
You mean by publishing it, I'll get a better
Yeah,
idea.
basically like having a variety of people
Yeah.
basically test it.
Yeah. I mean, the thing is also, I'm not trying to make this video something for everybody. That's specifically what I tried to do from the start is like, I guess if I had to describe it with words, it's like, if I was just randomly watching YouTube videos and I, in theory, like, didn't have all this, like, if I was back to being 18 or 16 years old or whatever, what would have been the perfect video for me to randomly find on YouTube? That's what the thought process I went at it with. It's like there's a certain kind of thing that resonates with me personally, and I can only understand that. Like, if I try to make a video based on what I expect people to respond to or what I expect to resonate with people, instead of making it based on my own personal instinct, it'll automatically be a worse product because I just understand it less well. So the whole way through, I just decided to make it like, well, is my experience with life and my perspective on it, like, is that something that is related at all to what others are experiencing? And is it maybe kind of like an aggregation of what most people generally experience, let's say, or something like that? Essentially, if I create something that resonates with me, will it resonate with other people? That's what I'm finding out, basically.
Yeah,
But
yeah, I see that.
yeah, maybe it's too complex or whatever, but there's no other way for me to do this correctly.
And no, it's not complex in a bad way. It's just that it requires you know more knowledgeable people to give, uh, I guess, like beneficial outlook or kind of fruitful
Yeah.
feedback.
Also, it's easy to forget about selection pressures. Um, oh yeah, I'm not too worried about feedback actually. I mean, obviously, I'll listen to what people have to say, and I want to improve this as much as I can. But there will be many situations, I think, where people will say, "Well, maybe you should do this," and I'll just say, "No, I don't like that," and then I'll never think about it again. Um, but like, I don't know, making the whole video in dark mode, for example, that was another guy's idea, and then I just thought, "Oh yeah, that's perfect," and then I just did that. Um, so that's kind of how I'm going at it. Like I'm not seeing it as like it doesn't, I'm not seeing this as a compromise between what I want and what the viewer wants. I'm seeing it as like a process where the kind of people who watch it will be similar to me in a way where their suggestions will be things that I like anyway, and that makes sense to me anyway.
So let
Um,
me ask you.
like I don't know, let's say,
I've gotten to this question. So would you say you are trying to build an argument for yourself about this video that is perhaps like people to follow or contemplate, or would you say it's just
well, it's about much more than that. Okay, so the first video is obviously very technical, okay, technical, no, not technical, but philosophical and abstract, let's say. You could easily make that argument, obviously. The point isn't to have like a philosophical video so that people can think about it and because it's interesting or something. Um, what I'm specifically trying to do is to create a new belief system and moral system for people to basically. Because right now there is no overarching moral system and people are, you know, it
you
seems
mentioned
to
to
me
it also, huh?
that there's nothing overarching except for emotions, essentially, in isolation. It's like, if you go to the video again, oh yeah, wait, no, this isn't in the one I
Oh
uploaded.
yeah, there's another one.
But
You
because I
technical.
haven't uploaded the final version. Yeah, the second version I'll still do. I mean, it's finished, but I still have to upload, right? But anyway, one slide that I added is that I'm talking about how the word poor used to be a more all-encompassing word instead of being like, poor in terms of you don't have much money or whatever, or poor quality in terms of a material is bad. It's like the word poor was just overarching low quality. And then I took the example of rich, because it's the opposite word, but it has a similar, let's say, background history, where it used to be more all-encompassing, and now it's just used in isolated contexts. Like you can still say, for example, that a dessert is rich and that a person is rich, but those just happen to be, you know, there's no connection in between the two contexts in people's minds,
The,
even though they're using the
so the
same
word
word.
or the
So
language has
basically,
more.
what I did is like a graph where it's fragmented specifically. Um, but basically, what I show in a graph is like I'm showing images of the different examples for rich. So I just Googled rich dessert and I got like a picture of like a really tasty looking brownie with a massive dollop of ice cream on top. And then I Googled rich man and I got a picture of Jeff Bezos bathing in money, basically. Um, and I did that, and I went down the checklist, and then I went like, I drew a bunch of arrows, and they point like to the concept of richness itself, right? And then I noticed while making this graph, wait, in isolation, the fragmented parts of the concept of richness all are leading to excess. But if you put all the different aspects of richness together into one single concept again, then it's just representative of a high quality existence. Like if yeah, basically. So what it seems to me is that there's a lack of overarching things in life. And what I basically, for example, here's a video I'm going to do next. It's like almost all of the following videos are just going to be about specific principles. Because like a principle kind of guards you against complexity. Because it's like if you have the correct principle, you don't have to think about the complexity because the principle already gives you a conclusion.
Yeah.
So I'll be making a video about economic principles, for example, but I'll also be making something about addiction and in what situations to trust your emotions and when not to, and that sort of thing. Um, I'm basically trying to make a guide for how I'm trying to make a moral system and like a guide that actually works in the modern world because there's really nothing that exists right now. that like there's no belief system that works in a modern industrial world,
Yeah,
basically. That's
that's
what I'm
very
trying to make.
intriguing, and I recall talking about this from the duration of the video that we have finished. I say that there isn't, I've described it, an overarching way to navigate our day-to-day life. How should we basically like behave? Or how should we
Yeah,
think about our actions? It's something that we're lacking, especially as
yeah,
being not following any particular religion, because that's what religions provide for us usually, like
yeah, exactly.
simplified.
Yeah, it's like yeah, that's what religions are to a large extent. It's partially it gives you automatically a community of people that you can trust because you all believe the same thing, which is a massive shield from anxiety, let's say, or from I mean, it's not like the anxiety that exists if you don't have a group of people who you can trust. Like, it's not like that anxiety is some defect, you know? Like, it actually does matter. And if the anxiety was gone, but the overarching structure was also gone, it's like things would still fall apart even if you didn't feel anxious. Like, the anxiety shows something real, always. But anyway, you know, that's basically what a religion gives you. And you could easily make the argument that what I'm making here is a kind of religion.
Yeah,
Um,
it's kind of
like
systemic way.
you can't. I mean, the thing is though, yeah. But the thing is though that it seems to me like you'll see this at the near the end of the video, like okay, half an hour before it ends, basically. Um, but basically, what I'm showing is like that. It seems like ritualistic organizations or religious organizations, whatever you want to call them, they're always putting either masculinity or femininity at the top. Like African tribal rituals are always femininity oriented. Um, like they're always, well, I get into the example there, right? But it's like circular
Um,
rituals around a central fire, for example.
maybe,
Though that sort of thing. It's like
maybe we can clarify
and
this
and and
further.
so you either have that or you have masculine
I'm
rituals. Hmm?
maybe we can clarify this further. Uh, I'm wondering.
Well, I'm clarifying it a lot in the
No,
video,
no.
but essentially
I mean, what do you
different.
mean by masculinity and femininity in this case? Is it in relation?
Okay, for so again, if you look at the diagram in the video, it's like there are a bunch of associated traits with
So
masculinity and
this
femininity. So, for example, the distinction and
it's like
diffusivity
a
thing.
grouping. A grouping.
Hmm?
We take a concept that is familiar to us humans in terms of our or a particular sex, and we expand on it to make it like a mean thing
Well,
bigger.
no. That's the mistake that's easy to make. So, femininity itself and masculinity itself are the most fundamental forces behind
So
existence,
it's not in
right?
relation to
Human female.
not in relation to human sexuality. So you consider it something more fundamental,
Well, obviously it is, but that's just because human. It's like
helpful concept, right?
you know when biological when biological sex dimorphism first evolved, like why do you think that evolved? You know, why does femininity and masculinity evolve biologically, and why did sex reproduction evolve
Yeah,
biologically?
that's
It's
in
like is that just some coincidence, or is it just that life is following the pattern of
I like
existence anyway? You
what
know?
you're meaning to say
So,
is why
but what I'm
didn't
trying to
life
say,
develop sexual reproduction? Or there are some
no, I'm saying, yeah, why did life develop sexual reproduction, and why did that turn out to be the most, like, why do all of the most advanced organisms reproduce sexually?
uh,
You know, is it,
could that answer be
and
arrived at
that
from
seems really obvious.
like biological investigations have certain advantages and so on?
Yeah. That's the thing. You can give endless amount. Yeah. Look, that's this is exactly the thing. You can give an endless amount of rational arguments for why masculinity and femininity evolved, but the problem is that that's all rational.
Hmm.
So it's like there obviously, yeah, you can say, okay, when egg cells first evolved, it had this and this and this advantage, but that would be missing the overarching point. And the overarching meaning is that masculinity and femininity themselves are the most fundamental forces in existence. It's why that all processes from the Big Bang to neurobiology to the first tools humans ever evolved to sexes existing. Um, it's why everything, it's just a fundamental pattern for all of these different things. That's
So
what I'm
you
trying to show.
consider them
Is that,
appearing in biological objects as well, some form of femininity and masculinity. Is this what you mean by them being more fundamental?
well, when I say femininity and masculinity, I really just mean concepts like
Yeah,
chaos and order.
the
It's
duality,
like,
right?
or material versus
Yeah, I get you
abstraction.
now.
Yeah, just the dualistic nature of existence, if you want to use that phrase. But
I get it.
yeah, so that's what I mean. I don't mean human, when I say femininity, I don't mean what human female people are
That's what
like.
I got as well. It's
That's
like
not at all.
something
I
that
mean,
we could relate with
okay.
because you say like femininity.
Yeah. Yeah, that's the problem. It's like I kind of feel like a lot of words and a lot of concepts have just been dragged through the dirt by people misunderstanding them fundamentally.
So you think so?
Um,
So
like
is it
but
really the case that femininity and masculinity used to have more general definitions, or they are ascribed ones that are?
well, yes,
So
obviously.
that's really the case.
I mean, just obviously. Well, yes. Hey, you'll see crazy examples for that, or one extremely crazy example for that later in the video when you get there. But yes, it's like
Yeah, interesting.
yes, they're the most
I don't know the
fundamental.
origins of these words.
I mean, look, it's like chaos. Okay, what things are there besides material and abstraction? Like what else is there?
Dual things are things that are dual in nature.
Well, yeah, no, I mean, this is not a rhetorical question. Like, what else is there besides material and abstraction?
You mean
As far as I can tell, there's nothing.
real and abstract?
Yeah, that's what it. Yeah, that's what it means. That's what this whole thing means. They are the most fundamental aspects of existence,
Material and abstraction.
and
The
that's why
physical,
if you try to imagine, and that's why if you imagine something without those two aspects, it doesn't exist.
that's like what is physical and in the realm of thought. That's how I see it, the abstract.
Yeah, that's one example for it. But yeah, that's
Abstract.
okay.
Well,
Yeah, anyway,
let's
so that
continue.
aside,
Yeah,
what I mean with religions either put femininity or masculinity,
let's
huh?
continue. Where were we?
Yeah, yeah, yeah. So when I said that religions either put femininity or masculinity at the top, um, so for example, that in African rituals they are femininity oriented. What I mean by that is obviously they form circles. Circles are inherently like that's like if you look at the most fundamental symbology or whatever that exists, it's like femininity is the circle and masculinity is the straight line. And the cool thing actually is if you only draw circles and straight lines, based on that, you can derive all shapes in existence, like hexagons, octagon, like any shape you can draw perfectly based on just making circles and lines. Um, but anyway, um, so basically, when you form a circle of people, um, and you compare that, yeah, I'll stay at the circle. So, for example, where does a circle end and where does it start? It's like, you don't know. It's impossible to say because it's like it's the idea of the individuals are diffused into the circle, you could say, into the group of people who are arranged in a circle, where and you know all the other aspects like dancing in a group, let's say, it all serves the role of ego diffusion. Um, so making the individual less distinct in the group. And again, diffusion is feminine, distinction is masculine. If you look at a church, um, you know, one of the most fundamental parts of Christianity is that the religion is about strengthening your individual connection to God. Because, you know, otherwise, why the hell would you ever pray? You know, prayer is about the thoughts existing inside your own head. And you get judged for your own actions by God. And the churches are organized in rows of benches, like rows and columns. That's how churches are organized. That's how you sit. And you're all looking at the same thing. So, you know, in the church, everyone is looking either at the pastor, or they're looking at the crucifix of Christ, which everyone's attention is directed to. So, and then the pastor makes a sermon where he's speaking. So it's like an abstract conveyance of information, where in a tribal ritual, it's the opposite. It's not about it's not about abstract information being transmitted. It's about acting things out as a group, like dancing and singing, let's say.
Yeah.
Um, and there are way more parts of this that I go over in the video. But yeah, and what I want to do is to create a belief system that puts both at the top, basically. That acknowledges that the role of living beings is to align themselves with the larger structure of existence. That's the rule that all animals have and all humans have. Every cell has all of that, and yeah, part of that is self-evident because you yourself and I, you know, will both inevitably die no matter what. But life itself, you know, we don't know for how long that'll continue or if it'll ever stop completely. So we have one thing that'll definitely end and another thing that might not ever end. So obviously the thing that might not ever end is automatically the most valuable thing out of the two. Um, yeah. So
That again. So
that's what I'm trying to create. So you could easily say that
can
that's
you
a
clarify
religion.
that again? So what are the two systems you are considering in your beliefs? Or yeah, you
The
mentioned
two
that.
systems? Oh, I mean, I go into that in more detail in the video. So if you want, we can talk about that more when you've watched the video, because otherwise I'm just repeating. Like I've already repeated myself a
Yeah,
lot, right? But so
sure. Uh,
we can talk about that though. Like
yeah,
I'm happy to talk about it.
yeah,
It's
yeah. I'm
just,
really
you know,
enthusiastic.
it's easier for you to understand anyway with the video
Yeah,
where you have
yeah.
the images.
No, especially with all of the hype that you built around it. My enthusiasm is increased. Yeah, it has increased.
Oh yeah, well I hope it doesn't disappoint.
No, so far it's been intriguing for sure. So let me tell you my initial impressions. I like your sort of so basically all that you are presenting. They're somehow novel and not not things that I could immediately recognize. And I also appreciate how you've. I like your neutrality, your sort of.
Oh,
Yeah.
thanks.
I really like it. You have a good way of expressing your information and doesn't come off as like how it is. I guess it's more like easily intuited, or it doesn't draw. Yeah, it doesn't draw
Oh,
upon
nice.
really complex, like any sorts of ideologies or ideas that the viewer needs to first have in mind or have like a specific amount of pre-established knowledge to follow along. That's what I'm liking about it so far.
That's really good to know,
Yeah, because
actually. I was extremely worried about that maybe
no,
being the
because
case.
it's often the case with intellectual matters is that this is how they build on top of.
Oh, sorry.
It's okay. This is how they build on top of each other. Is that they take the what has been.
Yeah, and then you have to understand like 10 different philosophers in order to
Yes,
understand one
exactly.
video.
It becomes a sort of not very inviting for a newcomer because it already assumes a level of knowledge that the viewer
Yeah,
should have to follow along, basically. So yeah, this is what I like, and in general, throughout.
thanks. I'm really surprised that you think I'm being neutral because like the whole idea from the start was that I'm gonna say exactly what I think, no matter who I think
Okay,
is
so
getting offended by it.
let me clarify further.
Because it always pissed me off every time a YouTuber makes like some disclaimer where like, and by the way, I don't mean all women when I
Yeah,
say
but
etc., right? It always
yeah, but I
bothers
didn't
me when I
notice
see
it
that.
from you so far. Like you didn't make strong,
Oh, nice.
strong like judgments or like the way things should be, the way things should change. Maybe I didn't get to it yet, right? Like there are no strong
Maybe.
statements that I've heard so far. Because like the intellectuals, they like to build up their arguments like this, and then they hit you with it. It's like, yeah,
Yeah, and then make
yeah,
some
I'll
bombastic
exist.
conclusion that's obviously impractical and
Yeah,
never going to be
exactly.
achieved. But it takes like dude, so much philosophy, like so much of it seems to be just about taking some word that already exists and is very significant. Like I don't know, the word real, like whether something is real or not. That's a very useful concept. That's one of the most useful concepts and most universally functioning concepts that exist, like whether something is real or not. And then some philosopher will come and say, well, really, we don't know anything and we don't know whether anything is real. So, really, we should stop saying that something is like something like that. So, they're just taking something that works and just turning it into something completely useless and then, like, congratulate themselves on what a genius they are. Like, I really
Yeah, I
hate that sort
imagine
of thing.
that goes around.
Or just make like a bunch of bombastic assertions based on no evidence
Yeah, I imagine.
whatsoever. I mean, it's part of what I'm doing, but
Yeah,
still.
but you are doing them from your own understanding and your own processing. We could say, yeah.
Yeah, I'm trying not to be pretentious, basically. I'm trying not to say things because they sound impressive. I'm trying to only say things that I actually believe and where I really believe that it's reasonable to
Yeah, it's
say.
good. It follows along nicely like this because I think many of us have learned to develop awareness of people with these sorts of grandiose ideas because it's often or it's something that we see in history how these sorts of people usually have an agenda, right? Or they're trying to somehow like
Mm. I mean, I have an agenda. That's the thing. But I think, okay, here's what I think is going on. I think that because no, if you don't believe in an overarching meaning structure, it's impossible for you not to be insanely egotistical. I don't know why I believe that, but for some reason that seems self-evident to me. And I think one of the fun, and I experienced myself being like this, by the way. Like when I was in a relationship with like I was insanely controlling. So like, but this was before did worked on all this
yeah,
stuff.
I see.
But basically, I think when you're ego oriented, you can't help yourself. You have to shove things down everyone's throats. It's impossible for you not to do it. And I don't know what that means intellectually, but I know that it has a certain feeling and a certain mode of action where it's like, I don't know, it's something like that instead of relations between people not being based on mutual respect, it's instead based on some sort of
Of your
like,
self-interest.
it's based on some sort of conformity based on anxiety.
Is it?
I mean, if you're long-term oriented, it's not in your self-interest to create stupid, oppressive social structures, let's say. But, or, I mean, I don't even know, I don't mean this politically, by the way. I just mean like, for example, I'm in a Discord server. Like, don't ask me how I got in there, but I'm in a Discord server where um, basically everybody seems to, or everyone that I see active there seems to be a really, really fervent left-wing Marxist sort of person. And what I notice is that like they're mocking each other for really, really minor things, like all the time. And it seems like, and if you don't kind of just play along and accept the mockery in a joking or playful way, even though it obviously is mean-spirited, you'll just be mocked even more and more and more and more, basically. It's kind of like a totalitarian system, but just in a Discord server of supposedly friends. It's really weird, but there's something really unsettling about that. Um,
Are pre.
but
They're
what was I trying to say? Oh yeah, yeah,
pre
right. The
left-wing
egotistical
Marxists.
aspect.
uh, Getting intentionally
Yeah, but
mocked.
I mean, I think this particular
Yeah.
political belief thing. No, I mean, I the political belief system is a little beside the point, but I mean, not completely though, for sure. But it's like this kind of the behavioral pattern is more important, where it's like they're resorting to sources of anxiety to maintain their kind of social interactions somehow. Like I don't know how this even works. I don't know why this social group even exists. Like I really don't. I mean, it's a fashion Discord server for a particular kind of genre, basically. So that's what it's based on. But like why the social group exists despite them being like so like emotionally hostile towards each other, it's really strange to say, but really hard to say for me. Um, but it's so strange. Every time I look at it, it's like they're so mean-spirited, and every time they argue about like, and I see them argue with each other over the most insanely insignificant details, and like people like, okay, for example, two people they were talking about like two of the regulars on the Discord server. They were talking about well, they're trying to figure out what a specific fabric in a specific piece of clothing was, because the fashion companies usually don't say what it is if they can help it. Um, and basically, one of the people said, "Well, on the label it says it's made in Czech Republic, so probably the fabric is probably also produced in the Czech Republic." And then another person said, "What? That's not, basically saying that that's not how it works and all that." And then there was this like really, really emotionally, like I could just feel the emotion like coming through from the text messages, right? Like this really hostile argument over something that's just so insignificant. And it's like, why? Well, if you're massively ego oriented, that's exactly why. So there's some connection there between being ego oriented and automatically not being inspiring and having to resort to anxiety to bring people together in some way. But this is
It's
obviously a
like
very vague
friendship
idea.
forming from.
I don't know. Have you ever experienced something like
I
this?
usually stay really away from any sorts of these kinds of friendships or social groups.
Well, yeah, me too. It's not
Yeah,
like I interact with these people.
yeah.
If I
I'm
can,
definitely.
Yeah, but like it's
Yeah,
so
I'm
interesting to
definitely
observe,
against
right?
bonding through aggression or violent behavior. That no, but
Well, yeah,
people like it, right?
obviously. But I mean, I think that's kind of like saying that I'm against.
Some people like it,
Yeah, but
roasting each
it's
other.
kind of like saying, well, I think
No,
murder
but
and rape
it
are
really
bad.
happens. Like there are friends.
Yeah. I mean, obviously. And everyone, and if you asked everyone on that server, if you ask anyone on that server if they agree with what you just said, they would all say yes. But I think it's
Um,
like, it's very, very easy to agree with some ideal that's
maybe
obviously the best
maybe they're
option.
already
But, you
they're
know,
already linked with it. Not escape it as sort of the lifestyle they built.
I mean, I don't know. It's just, you know, I guess what I'm trying to say is this. If you asked Stalin or Hitler, do you think good things, like if you ask Stalin or Hitler a bunch of questions about like obviously bad transgressions, like moral transgressions, they would give the same answers anyone else would give. Like, yes, I believe that unjust violence is bad, and that sort of thing. And yes, I believe that being hostile and rude towards people for no real reason is bad. Anyone would say that. But that doesn't mean that because you understand that this is destructive to social relations, let's say, that doesn't mean that you automatically know how to prevent this behavior from manifesting. So, yeah, if I ever understand this well, I'll definitely make a video about it because it seems like there's something there for sure. By the way, dude, I kind of have to
Yes,
go.
sorry, as me who forced you to be though didn't want to.
Dude, we've been talking for more than
Yeah,
3 hours.
yeah.
Or little, 3
Hope
hours
it
and
was
three
as
minutes.
engaging for you as for me.
Hey, I think I might actually make a second channel and put this recording up there. It's like this, I think a lot of people will want to listen to this. Maybe. If people watch the first
Perhaps.
video, maybe.
So, would you like us to?
Yeah. Well, anyway, I gotta go, but it was
Okay,
nice talking to you.
then.
What's your name, by the
Call me
way?
actor. If you could.
Okay, then, actor. Well, my name's Martin. Um,
If we could.
all right. Well, anyway, I gotta go.
Uh,
So, see you some other
okay.
time. Talk to you some other time. See you, dude.